Good morning! This is day 2 of the New York MariaDB Server Fest 2020. We will start the day by a presentation that I've seen in an earlier incarnation this year, February, at FOSDEM in Brussels, the Free and Open Source Developer Meeting. It was a presentation by Peter Zaitsev, who compared MySQL 8 with MariaDB 10.5. And not just on a feature-by-feature basis. I think this is a more philosophical, basic discussion of where the two products differ. I thought it was great, and that's why I invited Peter to also give this presentation at the MariaDB Server Fest. He will be followed by Sveta Smirnova. Sveta will then go into more of a feature-level discussion on the latest, in the latest MariaDB version. So the title of her presentation then is Modern Solutions for Modern Database Load, Improvements in the latest MariaDB versions. And the point here is that we do want everybody to get to know the features that are a bit underused and have been in existence already for a while. Then Sveta will continue. She will continue about a key topic that goes throughout this MariaDB Server Fest 2020, which is migration. Migration is happening constantly with MariaDB towards MariaDB from open source databases and closed proprietary databases. Other presentations go into Oracle, and here Sveta will talk about migrations from MySQL to MariaDB. And her title for that presentation is How to Migrate from MySQL to MariaDB Without Tears. She's followed by Richard Bensley. Richard Bensley has a title for his presentation called SQL Mode Ludicrous. And that's a slightly cryptic title for a presentation. What it's about is about practical things that he has learned, where we talk about underused features or tips and techniques for getting things done with MariaDB, including SQL modes, some of which can be a bit dramatic and have bitten him in some context. So that's why I'm very much looking forward to Richard Bensley's presentation. He is followed up by a colleague from MariaDB Corporation, Sergei Petrunia, and he will walk through the optimizer traits. So Petrunia is a core developer of the MariaDB optimizer, and if you wish to learn how the optimizer works in order to get more performance out of your application, then understanding how the trace really works is a good starting point. Then we will have two presentations by Seppo Jaakola about Galera. So he's from Codeship Galera, and we asked him to do two presentations at the Server Fest. I think he would, by himself, just want to take a deep dive at the latest features of Galera cluster and talk about what's new. But I think many of you do not know Galera well enough, and it's a functionality in MariaDB multi-master replication that really needs a closer look. So that's why we asked him to take a step back and give an intro to it, an intro to Galera cluster for those of you who are not yet familiar with it, from 0 to the latest version. And that's his first presentation. It is simply called MariaDB Galera cluster. The second one is then the one that he would by nature himself just concentrate on, which is the latest stuff, Galera clustering in MariaDB 10.5 and beyond. So a bit of a look at the roadmap as well. And then I'm excited to have Robert Hedgepeth present. So this is about MariaDB SkySQL. It's a commercial offering from the MariaDB Corporation, a cloud offering. So the presentation is called MariaDB SkySQL Next Generation Database as a Service from the source. So what are the functionalities of SkySQL and how is it integrated? Does it build upon MariaDB Server itself? So that concludes the second day of MariaDB Serverfest in New York. One more thing, some highlights from yesterday. Those who viewed us yesterday might have noticed that we had a couple of glitches when it comes to connectivity, but we're so happy about the whole concept of having the films already present. So we got a very shaved version of Valery Kravchuk with Monty as his stand-in, and then later on a slightly less shaved version with Vincenzo Ciorvaro. What was also great yesterday was the interactions over Zulip. So I want to remind you, please do so today as well. The discussion can go in both ways. Sometimes the presenter asks questions from the audience, but above all, there's interaction between the people of the audience and with the presenter directly, because the presenter is present on a live chat. When the presentation is done, it still remains live in the live stream. Over the course of this conference, what we're doing is that we're putting just that part of the live stream onto the URL that has been constant already since the very beginning of the conference. Let's take the Supermetrics presentation. Its URL is mariadb.org/fest2020/perfectdb. That one currently contains the live stream, but very soon it will be just the presentation by Dupes and Victor. These URLs are then meant for easy reference when you want to share it after the conference with somebody else, and of course for social media. So we're happy if you share the presentations that you liked using their URLs over LinkedIn, Twitter, your favorite social media. And then as the final thing in this one more thing part this morning, we are going to name the sea lion, and we will ask your help to do so. And you can submit your names. Stay tuned for the exact rules. We want to know why you suggest a certain name as well. And the winner will be picked. The winner of the choice for the name of the MariaDB Sea Lion will be picked by Maria herself, and the award will also be artwork created by Maria. But now let's get going with Peter Zaitsev and the MySQL 8 and MariaDB 10.5 comparison.
Hello everyone. Today I'm going to talk to you about MySQL 8 and its difference from MariaDB 10.5, the comparison between two wonderful databases. I have relatively little time for this presentation, so it will be mostly high-level comparison. Now, the first thing, which I think many of you are aware about, is what MariaDB is not MySQL. And while MariaDB started from the same roots as MySQL, and the first versions of MariaDB were very similar, right now they have diverged substantially, and I would rather see them as two great but also quite different databases. You can still run some applications on both MySQL and MariaDB, but especially if you are using the new features introduced in those databases, then portability between them may be harder. Now, me, being a CEO of Percona, which produces a product which can be seen as a competitor to both those products, it would be hard to claim absolute fairness, so I will pledge fairness of being offensive enough to both of those technologies, and you folks probably will disagree with plenty of stuff I will say here, wherever you are MariaDB users or MySQL users. So let's dive right in, as we don't have a lot of time to spend. First, let's look at the development model. If you look at the MySQL, it is developed by MySQL team at Oracle Corporations. Contributions are accepted. Even from us at Percona, we have contributed a fair amount of small patches, though we're not the biggest third-party contributor. All right, but while contributors are accepted, the MySQL practice what I would call the dropship open source model. That means the development is not done in public, but when Oracle chooses to do a release, the source code appears on GitHub as well. With MariaDB, the MariaDB Server is released by MariaDB Foundation, but I would say what development and roadmap are mostly driven by MariaDB Corporation at this point. Contributions with MariaDB are not only accepted, but they are also encouraged, and development is done much more in the public, especially when it comes to the server side. What is interesting though in the MariaDB case, there are those two entities, MariaDB Corporation and MariaDB Foundation, and I, as an outsider, find this relationship to be super unclear and complicated. For example, MariaDB Foundation is responsible for MariaDB Server, but many other connectors, which you would argue are also necessary parts of the complete solutions, are owned by MariaDB Corporation and released under a variety of licenses. Now, even what you would consider Docker server parts, such as MariaDB Docker builds, are provided by MariaDB Corporation. Now, there are also other bits and pieces which I find interesting. For example, MariaDB knowledge base, which a lot of community contributes to, is hosted and controlled by MariaDB Corporation, even though you would potentially see that as a community project. Now, I also found this interesting experience just a few days ago. If you download something from mariadb.org, you would, after download completes, redirect it to the MariaDB Corporation page, which is, as you can see here, is a form which shows what you are providing the data to MariaDB Corporation, and may choose to share that with MariaDB Foundation as well, while that is not what I would expect as a user, right? If I download something from MariaDB Foundation, I would expect that is where my data would go, and not to MariaDB Corporation, which may use that for a different purposes. The next step, or next question, is what is really open source and what is not in those in MariaDB and MySQL ecosystems. MySQL follows a very clear and simple open core model. So if you think about a MySQL platform, there is a community version of a whole platform, like for example, MySQL in a DB cluster is the high availability solution, which is completely open source, includes open source router, and so on and so forth. And then there is an enterprise version, which is a commercially licensed tools and plugins, which are more powerful, of course, right? For example, you would get MySQL Enterprise Monitor, right, with a variety of graphical user interface tools only in enterprise. What also I think MySQL has done very well through history is there have been no components which initially came as an open source and then were relicensed under proprietary license as a community got some traction. In MariaDB space, MariaDB Server is open source and MariaDB connectors are open source, but there are also parts of solutions which are not. For example, if you are building high availability environment with MariaDB, the default and recommended choices to use MaxScale as a router, which is not open source, it's business source license. And also the story with MaxScale is complicated because it was started as an open source project, but then later moved to the proprietary license as it got some adoption, which some people may consider as a form of bait and switch. MariaDB Enterprise Server is also an interesting kind of open source, right? Obviously, MariaDB inherits a lot of a GPL code from MySQL, so we can't really close source the servers. But what they can choose is to distribute the MariaDB Enterprise source and binaries only to customers, and that is what I mean by open source for customers. You can also see Expand Storage Engine, which is something which came through Cluster acquisition, is only available in that proprietary version of Maria Enterprise Server, at least at this point. Now let's look at also about the relationship between the open source and the subscription version. In MySQL, the MySQL Enterprise is superset of MySQL Community. So wherever you use in MySQL Community will work in MySQL Enterprise and some more. There is also aligned release schedule. That means that the MySQL Enterprise of certain minor version and Community, they release at the same day. In MariaDB case, MariaDB Enterprise Server is extended subset of Community. It includes some additional features like Expand Storage Engine, right? But there are also some features which are available in Community version which may not be considered mature enough or not included in the Enterprise or MariaDB Enterprise platform for one reason or another, right? And also MariaDB platform has its separate life cycle. If you think about the cloud native, right, and I mean by cloud native in this case the Kubernetes focused, here is a situation I think is very interesting for both the database technologies, and I am not using interesting as a complement in this case. If you look at the MySQL, there is an alpha version of open source MySQL Kubernetes operator which had last commit about 16 months ago, so it's kind of slightly dead. There are a lot of third-party Kubernetes operators and Helm charts, right, other packages available for MySQL from Presslabs, Percona, and a whole bunch of other third parties. With MariaDB, the Kubernetes operator was actually announced as one of the launch operators during the Operator Hub launch by Red Hat. But since that, it was pulled, and if you find that page in archive, a press release or Operator Hub, you will get links not found, or I'm not sure what the exact story behind that. At the same time, there is a commercial MariaDB Enterprise operator available from MariaDB Corporation. Right, so this is kind of puzzling to me, because if MariaDB Foundation focuses on the service side and the Kubernetes is really one of the modern ways how you distribute and consume software, I would expect that, as long as the Docker builds, to be on the roadmap for MariaDB Foundation to cover. And of course, for MariaDB, there is a very large amount of third-party Helm or operator projects exist, right? But that is just so foundational piece of infrastructure. If you would use that, you would really want something which is well supported. Database as a service. In this case, we have MariaDB and MySQL community versions are available on a variety of clouds: Google, Amazon, Azure, DigitalOcean, and others, right? And also MySQL serves as a base for Amazon Aurora, which I would call the most popular cloud fork, right? Which is something cloud vendor forked and didn't release changes. Now, both MariaDB Corporation and Oracle, they offer database as a service for their respectful enterprise versions, right? Which are not available on the other cloud, with exception of, as far as I could find, Alibaba, which also offers enterprise version of MariaDB through partnerships. Both MariaDB and Oracle's MySQL recognize that the analytics is an important part of a modern workloads, and column store engine, which first appeared in MariaDB platform, now is available in MariaDB 10.5, like as a completely open source solutions, while MySQL has MySQL Analytics service, which is available in Oracle Cloud only. As far as I have seen, it's not have been available either in community as or an open source edition so far. So where do we see the focus? If you think about MariaDB, it's initially competed with MySQL on features, getting features out there faster, right, and so on and so forth. But then MySQL was catching up with those, and I see in recent years a lot of shift happened. We focus on comparability and migration features from Oracle, Microsoft SQL servers. Really, a lot of usability for sysadmin DBAs, like for example, startup scripts or like shell highlights and so on and so forth are very good in MariaDB. And more recently, I see that as a cloud integration and general cloud integration, such as support for S3 storage engine in MariaDB 10.5. MySQL focused more on the traditional MySQL use cases, trying to make MySQL better MySQL. It also worked on improving SQL support, CTEs, windowing functions, like some of the things which appeared in the new releases, as well as trying to tackle the NoSQL market with doc store and very advanced JSON features. Right? We really also focus on usability for developers. For example, MySQL shell, which includes integration with JavaScript or Python. And with a cloud focus, MySQL focuses on the database which can run best in Oracle Cloud rather than general clouds. Also, other clouds, of course, benefit from a lot of features being added to support Oracle Cloud, but that is less priority. And we see MySQL is not focused on advanced Oracle features, right? And there is different theories I have heard about that. Some of them I saw is because the customers, what Oracle has, they're not asking for those advanced Oracle features because they already have Oracle for that. Or maybe that is a product strategy not to disrupt or big Oracle database, right, with MySQL. You can make your own mind here. If you think from an architecture approach, MySQL really started in the recent version painful refactoring on an old code base. We can see in the DB data dictionary problem was tackled in MySQL 8. They introduced Vulkan optimizer. There is a really focus, I think, on prioritizing ease of use and limit choices, saying, hey, you know what, we're not going to really have a lot of storage engines for everything. Let's not have users think about that. We'll just have one default InnoDB storage engine. We'll try to make work for from everything. But at the same time, I think some decisions MySQL took were kind of needlessly complex and sometimes disconnected from reality, right? For example, MySQL GTID's introduction in the time was, well, quite a fiasco, right? For MariaDB is more focused on pushing old code base further, right? It didn't have such a massive change as MySQL took in MySQL version, but really it prioritized a lot of choice and flexibility, support for multiple storage engine, right? And really its development team, I think, is working much closer with the customers and much closer to understanding the practical operations problems sysadmins, right, and otherwise would have. Now, in the recent years, MariaDB also acquired some InnoDB developers, and it has its own philosophy and roadmap on making InnoDB better. And now I think we have a very fun opportunity to compare the Oracle's InnoDB to MySQL's InnoDB to see which one performs well. And I think that is fantastic competition, which we will probably benefit users overall. Here is example of release frequency. If you can see what MariaDB releases much faster than MySQL. If you see in this case, MySQL has a major release every 2-3 years, right? And we don't know when and if next MySQL major release is coming. MariaDB has been working last 4 years almost like a clockwork, releasing the new stable release sometime in May or June every year, right? So very different life cycle. Though that doesn't mean that the MySQL is moving very slow. The release philosophy is also very different. MariaDB continues classic MySQL philosophy, where you have relatively frequent major releases, and then there are no major changes in minor releases. So that's kind of mostly bug fixes and small tinkering, right? And that also means that you can do both upgrades and downgrades, keeping dataset intact. The MySQL 8 is what is called evergreen release, right? It's saying, hey, you know what? We are breaking that old ideas. Now we're going to introduce features in minor releases. And what that also means, you won't be able to do downgrades. Okay, with that, let's look at some more technical specifics. What do we have in terms of client protocol? Both MariaDB and MySQL support classic MySQL protocol, but also MySQL has done some extensions. For example, it supports SRVD next record support, and I think the biggest new thing in MySQL is this thing called X protocol, which allows you to the new protocol, which you can use both SQL as well as a doc store protocol. In MariaDB, it has classic MySQL protocol as well as its own protocol extensions, for example, for progress reporting and some others. If you look at the interface support, MySQL, you can use classical SQL, you can use doc store, you can also use Memcache, talk to that through Memcache protocol. MariaDB supports SQL as well as handler socket plugin. If you look at JSON support, that is, I think, where MySQL is substantially ahead. It has a native JSON data types. It supports very efficient partial updates of large JSON fields. It has things like JSON shortcuts, which you can use conveniently inside of queries. Advanced features such as JSON tables. Where with MariaDB it has some JSON functions, but it also stores JSON as a text field, and there is, I think, a lot of work is being done in MariaDB right now to support JSON better. Replication. In MySQL, you have MySQL group replication and MySQL's GTID. Now it has added also a clone plugin for efficient provisioning, which can be used for both classical MySQL replication as well as a group replication. MariaDB does not support group replication. It uses Galera replication instead, and it uses also its own GTID, right? So replication is something which is a very different between those two databases, and in generally ways how you provide high availability, right? So that is something I would be looking very closely to. In terms of SQL standards and compatibility, I cannot find anything big which MySQL has which MariaDB does not offer. right? So I think MariaDB, well, outside of JSON, right, frankly. MariaDB, though, it adds SQL mode equals Oracle, which has a lot of Oracle-like extensions. It supports system version tables, right? Sequence. It supports packages and storage procedures, right? So a lot of stuff to compatibility with standard and with other databases. Now, if you want to look into the more detailed feature comparisons, you can check out these fantastic blogs on modernsql.com, though I would point out they are both now about 2 years old. It only covers MariaDB 10.3, and MariaDB 10.4 and 10.5 have more stuff. And also, actually, MySQL have been adding more features in the new MySQL 8 releases, right? So be careful with that. Security. There are significant differences in security and user account management. You know, how roles are implemented, privileges, the names, what corresponds to, right? So that is also something there are a lot of difference, right, if you're considering migrating between those technologies. Optimizer is another huge item which their database are very different. Right, I would see if you are moving some complicated queries between MySQL and MariaDB and vice versa. Really check out Explain for them, because performance for complicated queries can be substantially different. Right, and if you talk to both development team, MySQL and MariaDB folks, they both can point to queries which run better, faster on their platform, right? But in the end, what you probably should know as a user, hey, there may be difference here, be careful with that. Well, and with that, that is all I have. If you're interested to hear some more about the open source databases, including MySQL and MariaDB, I want to invite you to Percona Live Online in October 2020. With that, thank you. Let's keep in touch.
Thank you, Peter Zaitsev. Great presentation. Hello again, Durham, North Carolina.
Hey, thanks, Guy.
So not long ago, not many hours ago, I met you in virtual Paris. Now we're meeting in virtual New York. So as I said last time, you had a couple of observations on the relationship between the MariaDB Corporation and the MariaDB Foundation. I took the liberty of stealing a couple of tricky questions. Right after your previous presentation, we had an Ask Me Anything session with Monty. It will also be broadcast here in virtual New York. I hope it was fine to steal your questions.
Oh, of course, of course.
So to stay on something slightly controversial, another hot topic, people used the word drop-in replacement, or have been using that for MariaDB in relationship to MySQL, especially earlier days. And some people say it still is in practice a drop-in replacement of MySQL. And others then want to enter into religious global transaction ID, GTID wars. So where do you stand on that issue?
Well, I think the drop-in replacement is not super well-defined terms, right? You can range from a position where, well, all the relational databases speak SQL, right? And so you arguably can use them interchangeably, right? To all the way to if any application which runs in situation X could run if right, or with in situation Y, right, or product A and product Y, right? And I think if you and so a lot will depend on your definition, right? Obviously, MySQL and MariaDB, they still remain to be relational databases and speak SQL, and in most cases they do understand each other SQL, right? So from that point, you can still see it as a drop-in replacement. But now, if you look at the applications, right, using it, there may be certain differences. And here, I think a lot have been changing through years. If you look at the earlier MariaDB versions, right, I think especially 5X, right, before 10 came into a picture, those were really sharing a lot of code base with MySQL and have been very comparable. Now there is significant diversion in the features, right? Especially if you are looking to use some new features, either in MySQL or in MariaDB. And I think what you also have to be thinking about where things are going. And I would expect that difference to continue to grow as the product innovates with their respectful roadmaps.
Mm-hmm. So let's assume that I am a user, not on MariaDB, I'm on MySQL, and I'm on a release of MySQL prior to MySQL 8.0. So in this world of semi plugin, drop-in replacement versions, what are my options, and how should I be thinking about my future from that point onwards?
Well, I think it's in this case that is an interesting timing, because if you look at the MySQL world, the MySQL 8 takes a giant leap in many cases, right? In MySQL 8, a lot of the old conventions have been abandoned. A lot of old architecture has been changed, right? Hopefully for better, maybe for worse, right? Depending on your opinion, right? And if you are looking for something which still behaves as old MySQL and sticks to old MySQL values, yes, MariaDB may be in many cases closer, right? If you look at MySQL as, hey, what the MySQL will contain, that's obviously MySQL 8 track, right? And I think that is one of the things where I'm saying, hey, in the future, comparability more and more diverges, right?
Right. So listening to your presentation and also earlier versions of it, one of your expressions that stuck to me was evergreen release, which I understood to mean to refer to the fact that in MySQL 8, bug fixes and new features are not separated like they traditionally were in MySQL and that they continue to be in Maria. But they are mixed into the same release. So what's the effect of that? Whom does it affect? Is that an issue for application developers to think about, or for customers? Who has to think about that issue?
Oh, yes, yeah, absolutely. I think that is a big philosophical question. There are a lot of different, I think, approaches which exist in modern world, right? I mean, if you look at a lot of a traditional enterprise approach, right, it's often where we are looking about the safety, saying, hey, I deployed a given version of database. Want to make sure I only get bug fixes with minor releases, so nothing ever breaks, right? And that was traditionally MySQL approach, and that is approach MariaDB continues to focus on. The MySQL 8 focus on the different idea of saying, hey, we as developers, we want to make sure we get the new features faster, right? The faster innovation, and also the constant but smaller changes, right? So instead of saying, hey, once per year, I have to do this kind of a massive database upgrade, right? There may be a lot of things change and I have to go through all the changes in application. I get into the culture, what I need to review how my application was involved with every release, right? Like every 3 months or something. You can think about that as kind of more agile, like Scrum development, right? Ideas where there is a lot of uncertainty, right? And it's kind of moves quickly. And I think it's worth to note that the MySQL is not only project which uses this approach, right? If you look at, for example, how Kubernetes evolves, every release in Kubernetes, right? Even you can think about that minor one, introduces and depreciates a lot of stuff, right? So MySQL took the bet of a new approach, right? And I think we'll see. It will take years, frankly, to see to what extent that was a winning bet or not.
Yeah. So I think we have just half a minute left, but your question, what you're saying then is that customers don't ever necessarily get a completely stable release, but we'll see in the future whether that is necessary. Is that what you're saying?
Well, I think a stable release, right, is a completely stable release is not a word I would use, right? All the software has bugs, right? And I think that was even highlighted. Mantis Ask Me Anything discussion, right, from Zulu chat, right? The question is more about the intentional breaking changes, which is at this point MariaDB does not introduce, and MySQL does, right? To the point of, hey, if I upgraded MySQL from 8.0.20 to 8.0.21, my data format may have changed and I cannot go back, right? Which is frankly unpleasant new reality for many.
So sorry for interrupting at such an unpleasant point, but we're out of time, and your questions or your answers to the questions were very educational, as was your presentation. So thank you, Peter Zaitsev.
Okay, thank you, Kai.
And now Sveta Smirnova will talk to you about modern solutions for modern database load improvements in the latest MariaDB server versions.
Hello. Today we are going to talk about MariaDB improvements in the latest versions. First, before we get started, I want to introduce who am I. I'm a MySQL support engineer and MariaDB support engineer since I'm joining Percona. I'm author of book MySQL Troubleshooting, and I have a couple of hobby projects available on GitHub. I'm a speaker at various conferences, and today I'm going to speak about specific improvements which are unique to MariaDB Server. But before we get started, I want to remind you history of the MariaDB. MariaDB is fork of initially was created as a fork of MySQL, and MySQL first was released in 1995 by MySQL AB company. In 2006, Percona server, that's one more independent fork, was created. In 2008, company Sun bought MySQL. And then in 2010, Oracle bought Sun, and as MySQL was part of Sun at that time. So Oracle now owns MySQL. In the same year, 2010, original creator of MariaDB, Monty Videnius, and main developers, they were not happy with situation. They just quit Oracle and created own company called MariaDB. MariaDB started as fork of MySQL, but now it's independent product with hundreds of unique features, and which features are very different. Some MySQL doesn't have. But important, since origin of both products is the same, important improvements are backported from MySQL. So MariaDB has most important features from MySQL and also has own unique features. In this talk, I'm not going to talk about features ported from MySQL. I had another talk in past, and it's available online. So if you are interested about MySQL 8.0 features, you can watch a recording. And for those features which are backported to MariaDB, it's also applicable to this product. But in this talk, I'm going to talk about MariaDB unique features. And MariaDB unique features is Mostly like I put into two groups. One is optimizer improvements because MariaDB has a very strong optimizer team. And for example, MariaDB introduced advanced SQL such as Windows function or command table expression many years before MySQL did it. It also MariaDB is unique that it supports a big number of storage engines and other storage improvements such as data types. And this is focus arm of my today talk. And one of first feature which I want to discuss, it's called storage engine S3. This, as you can guess from the name, is data is stored on Amazon S3. It's very easy to convert. It can be used just like you are using alter command for and converting any storage engine table to use Amazon cloud storage. But underlying engine is area, so like it's practically you are converting your storage your table to area table, local area table, and that area table goes to Amazon as free storage. These tables are read only, and so that's a unique case for because like kind of. You probably like do not want to write much for remote storage, but for read-only, for cases like in case if it's not frequently used data, but you still need to store it, and you need still to keep it on a comparatively cheap storage, it's the best case to use this. It also has unique features, so it can use shared storage and separate and shared storage for replication. Like separate storage is like in case if you are setting up, it's the same like you are setting up source server and replica on the same machine, like for example if you are testing it's a laptop, but it's copies, like you have one copy of data directory for the source server and one copy for replica, but for S3 storage engine you can also share this data, so you can have only duplicates for tables which do not use S3 storage engine. It has own layer to connect to S3, so it's not shared API, it's own layer called libMaria S3 library. Another unique feature is column store, which is available since 2017 as a plugin. It was available in 10.4 enterprise version, and now it's part and it's included and shipped together with 10.5 community server release. This is columnar storage engine based on InfiniDB. It's but what is unique about this storage engine? It's has SQL interface and it's can communicate. It can be joined with SQL engines such as InfiniDB. One of common pains of people who have like heterogeneous environments or who move from SQL to columnar storage or vice versa, they have to set up jobs which get data from SQL storage to columnar storage, and they cannot combine them, and they have to maintain two copies and have to maintain them synchronously. But with column store, you can it's just like built-in, so you can have advantages of your SQL storage engine, and you can switch and you can use this columnar storage. MariaDB has many more storage engines, and here these are QR codes. So you like if you are watching here, you can use your phone and you can access links. Or after the conference is over, these slides will be available for download, and they are active links, and you can just follow these links. I do not explain about this storage engine in details because these are not new, comparatively not new, and well, if I do, it would be quite a longer talk. One more important feature of MariaDB is system versioning tables, which actually then when I joined MySQL as support engineer in 2006, and I was on my first MySQL user conference. Many people describe it how watches how to use, how like rollback changes into database, and for that time it was not like quite useful. You have to like maintain log and make like application label. But in system versioning table, you can use like your repository, like GitHub or like any source tracking version tracking system, and your tables have history. And you can perform, for example, point in time recovery on the fly. And I have here example. In this case, I'm using standard test database employees. It's available at MySQL website or actually on GitHub. I just like take it and change the table employees. So I added system versioning. So that's now it's standard employees database supports versioning. And if I run show create table employees, I will see it's just normal MariaDB table, but with this option, with system versioning. So what does it mean? What does it mean? It's like usually for queries, we can query it's like any other table. Like we can select, we can change rows. And mistakenly, I run delete from employees, and I removed all employees which was hired before 1986. It's a pretty large number. I thought false, like, oh, maybe it's a mistake, maybe I didn't do it, but practically I do it after commit is one, so it was committed, and I do not have records in my employees table with these employees. So what can I do? With system versioning tables, I can query time. It's like since it was just like now, so I took a period when I knew that my required record exists. So I just like query insert, query my employees table for system time between now and interval 1 hour and now, and where hard date it equals my condition, and I just like insert into employees table, and I have all my removed rows back. These system versioning tables, they are very tunable. So you can store not only time, but you can also store transaction ID. You can have history stored separately, like for example, like if you want to have maintain it in different physical spaces. You can partition like your regular table data in one partition and your versioning data is another partition. You may exclude some columns from versioning if you do not want them to be versioned. It's also possible to have time-specified time periods at application level. It's a little bit different syntax, and I did not cover it here, but you can do it. And you can combine both, like system version, like I showed just now, and application period lengths. And for another feature, it's also useful for previous one, so it doesn't show versioned columns. It's invisible columns. So what does it mean? Like sometimes you may have a table with a large number of columns. Like here, I want alter table employees and add a column address, which is JSON format, which is quite long and which can probably may have some even more than one address, or maybe like for some employee it can be just like country and a city, and for another employee it could be quite long. And also many could not just could not specify, just like I just started, and I not always want to see it in my output, and you can have like many such columns. In this invisible columns are not accessible for queries like select star. So like you are seeing here, it's like just employees table, like we saw in previous slide, but there is no new field. But if I query a new field directly, it's accessible and it can be visible, it can be used, and it also could be used in the functions like I'm using here in JSON extract. Another MariaDB improvement is sequences. Sequences by default, MySQL and MariaDB tables supported only after increment columns for sequences. So like you can have some ID column which started from 1 and then depending on after increment option, it's will create such numbers. But sometimes you want, but you can only have one after increment column in table, and sometimes you want some custom sequence numbers. In this case, you can for MariaDB you can create a sequence. It's was possible to imitate sequences, but it's always you have to create a table. You have to maintain. You have care about transactions, about atomacy. With MariaDB, you can just create a sequence. And like for my example, I create circles with odd numbers, which starting with 1 and incremented by 2, so it should have like 1, 3, 5, 7, etc. And another sequence called evens, starting from 2 and it is again incremented by 2, so it's like 2, 4, 6, 8, 10, etc. And I created table numbers where I put primary, like after incremented primary key, and 2 more columns with odd and even numbers. And here we can see its syntax. So default value, it's next value for the sequence name. So this way we can create table and have customized sequence numbers in there. And in case I put just like empty, something to insert everything default. And this is, I'm having like, this is after incremented ID, this is all our odd numbers and our even numbers. So it's pretty easy, it's very useful. It's can be used for situations when you cannot use standard after increment features. Another feature is both MariaDB and MySQL for a long time support IP version 4 support, have functions for it. And MariaDB has a new data type called inet6, and which supposed to store IP version 6 addresses. It also supports IP version 4 addresses which are incompatible, which has deprecated format now, and also mapped. It's a little bit like it has this prefix, and this is not deprecated, and this will be supported. It also supports functions which is for IP version 6, and like I put here IP version 4 compat is to find out deprecated addresses here. So it's more effective way than just store these IP numbers in strings, and also you can. It's more effective if you can, for example, compare to IP addresses. Another feature is wait and no wait interface for statements like querying tables or even for DDL operations. So what is this? With a normal table scan, like if you have 5 rows here, and one thread is doing some work and just logs, like for example now row 3, and second thread is doing scan, and it meets rows with ID 3, and then it waits. It's depending if it's an DB storage engine, it's DML query, it's in a DB log wait timeout seconds, or if it's DDL, it's waits log wait timeout seconds. But this is not sometimes what you want. For example, by default wait timeout could be set too high, and you want to wait less time, or vice versa, it could be set too low, and you want to wait more time. So you can just specify how many seconds you want to wait. You just add this to your SQL statement, and MariaDB will wait this number of seconds. And then either error or either read for rows. If you do not wait, you can specify a no wait keyword or just wait 0, and your query returns immediately with error. And this is very useful because default, for example, LTP log wait timeout, minimal value is 1 second, and 1 second it could be very long time. Like modern application can easily handle 100 sorts or even transactions per second, and this could be way too long to wait just 1 second, and it's much better to have error immediately. That's like kind of finish of discussion of storage and related improvement. Let's discuss SQL and optimizer improvements. One is aggregate stored functions. This is your own aggregate functions. It's sometimes like you are doing like you may miss some aggregate functions, which works in group of row, and you now can. And before you could only, like, if you wanted to create your own aggregate function, you have to learn C language and write UDF function. But now you can just create your own aggregate function yourself. To do it, you need to add aggregate keyword to the function name. You need to specify value. This is value which would be used for this function. And data type, like for my example, I use integer data type, but for your case, it could be any data type you want to this function work for. And for this function, I count positive values in some column. You must declare exit handler for not found condition, and you usually return the result of this function, but you need to just return something from here. And then in the loop, you can create loop, and you also specify fetch group for next row. So you are fetching next row, and you have access to value, like to the value, and you can do something with it. So like in my case, I check if value is positive, and it's positive, I increment result. And let's see how it works. In this case, I have a table called numbers, and I have some numbers in num column. It's some are positive, some negative, and so one is 0. And I have some color which I want to group for, and I have like for this color I have these numbers of positive and negative options. So you can see it's 1, 2, 3, 4, 5 positive values. So this is sum is correct. So this is how they are distributed. And you can tune and you can create aggregate function for whichever you like. And here it's like this is like these are feature which I discussed. Those features were introduced in version 10.3, 10.4, and 10.5. But I want to speak about these pretty old functions. But why? Because the another talk which I referenced before, it's about MySQL 8.0 improvements. It shows similar improvements. But for MariaDB, some of them existed for very long time. For example, roles were introduced in 10.0.5 version. So, but I still want to show them because, like, in case if you missed these options, and these are pretty modern and still interesting and very powerful to use. First, I want to speak about histogram. Histograms. What is a histograms? Histograms is not storage engine statistics. So, like before histograms, we had one way to use statistic about what is stored in our tables is indexes. And what is the problem with indexes? So, assume we have a table with 10 different values with data distribution. Like with value 1, we have pretty large number. With value 8, we have pretty small number. In case of indexes, we have only one value which could be used by optimizer. It's called cardinality, and this is same for all values, no matter which one it is. It's actually practically both engines, and MariaDB also has engine independent statistics have some extensions which allows to access to have more ideas what is about ranges of data here. But still, it's like just a simple way. For index cardinality, it works so, and sometimes it could be not useful. It's not possible to find out which index is better to use because we just for us it's same. It's like this number. It's big number of unique values of values here. It's small numbers here. For us, it's same. For histograms instead, they store they store information about unique values for each range. So in this case, we may like see its equivalent to 1, it's probably to 8, so that's smallest number of values and this biggest number of values, and we can see difference, and we can have optimizer can have better decision which which query execution plan to create. Another option is analyze statement. Which is a problem, it's when we are trying to find out how our query is executing, we are running explain statement. But explain sometimes telling lies, not because it's poorly designed or not because it's poorly written, but because it doesn't execute query. So it's just like it's estimate. So it's like it doesn't execute anything. It just thinks which optimizer will use when resolve the query. And for example, for this query, we are searching for 3 rows, and optimizer explain tells we are going to check 33 rows and use this this optimizer plan. But practically, when we execute the statement, it could be run slower. And analyze, it's the same as explain, but it executes the statements. In this case, we have more accurate data. So in this case, we are seeing we examined practically 100,000 rows. And here it's R rows and R filtered columns. R rows, it means it's actual number, which how many we examined. It's 100,000 rows. And R filtered is how many rows from filtered result set were left in the resulting statement after very close was applied. In our case, it's no 0, but it's practically not 0, but it's like sign free, it's probably free. It's just like it's percent, it just was rounded up this way. So it's like if it would be like limit 33, it would probably have 0.0.1. Another important feature which I want to show you is common table expression. It's may look complicated. It's kind of modern, advanced SQL, but it can make your life of SQL query designer it's much easier. So what we are doing here, we are using with keyword. We create a name of our result set, and we are using like kind of subquery. And then we can refer this subquery from our author query, and we can join with table with any other table, or with we can join with like depth data with depth data. We can create as many such clauses, such named subqueries as we want. We can refer that 2 times, and it's makes it much power SQL, and it's much easier to read than if you use like traditional subquery which were available before. That was not recursive common table expression, but MariaDB supports also recursive. That means we can refer to result by itself. So how can it be created? You need to create it with a recursive keyword. It's name of that expression. This is our 2 values. And these are initial value set, and we are selecting with our expression. So we're selecting ID from 1, and we increase it. And a second value is random number. And here is expression which limits, because this is loop. And this loop should start somewhere. So this is important part. We need to limit it somehow. And we are selecting from our generated data, and we are having like some table with random values. So that's kind of useful feature. Another advanced SQL feature is called window function. It's again is better to show on example. So we have like a very common case. We have some result set, and we want to have numbers which are incremented like ID. And before window function, it was pretty hard to do. We have like create some tables, we maybe create join. It was like just too complicated and sometimes hardly possible. But here you can select some data from select some data, and you can add function for this window. In this like called row number. In this case, we are just adding number of row, and with this function we select a unique name like ID. That's called window some random name for our window, and here we are using order by our one of columns, so we have our results set ordered. It's again, it's like you have to sit with it, you have to learn it, but after that, it's writing SQL is much easier than it was before. Another like long awaiting feature, it's again available in MariaDB for quite a long time, is check constraint, which helps to create custom rules violation. Without check constraints, you can just like use like kind of triggers, but and errors and raise error. But with check constraint, you can just like write a table and see like expression, and you want its expression to be true. Like in our case, I want to check like its value is even, so it's a modulo by 2 is equal 0. So if I insert even values, it succeeds. If it's not, I'm receiving error, and that's error not succeeds. And finally, it's again, it's important for privilege management. It's roles. For like what is like common MySQL DBA pain is to like if you need to add many users, you have like for example, if you have like similar, you just like want like readability for regular users, and you have to for each of them create like grant statements. And as a result, I'm seeing like as support engineer, I'm seeing people just like grant more privileges than this user need, and this creates security concerns and security issues in future. With roles, you can just create roles, and you can grant specific privileges to roles. Like for example, I created read only and admin, which has super privilege. And then I created a user, like just regular user, we are humans like Sveta and Kai, and some administrator user called privileges, and I grant read only to Sveta and Kai, and I grant admit option to privileged user. MariaDB also support default roles, so these are either default roles for a user or default role for any new user which you create. So conclusion, to conclude our talk, that's new versions have new features. MariaDB is unique that it implements advanced features very early and very fast. So upgrade to new versions to explore all MariaDB advantages. And here is more details. They are practically mostly links to the user manual. This is the FOSDEM talk by Sergey Golubchik on system versioning tables. This is MariaDB Day near FOSDEM 2020. It's talked by S3 storage engine after Monty Videnius, and others are links to the user manual. And again, it's more information about discussed features. More information about checks, constraints, and roles. And all data will be available on SwitchShare and announced on Twitter. Thank you.
Sveta Smirnova in Alana, Turkey. Thank you. Great presentation, and thanks for joining.
Thank you.
So you gave a good overview of new features in the latest versions of MariaDB, and I'm trying to group them into some kind of categories, and also what I would like from you is to get an answer about the question why do you think they were introduced, and you can give a propeller head type of answer sort of with the use cases, and you can also compare it to, well, it might have been introduced in comparison to other databases who already have that feature. So the two first ones I'm thinking about is the storage engines. S3 and column store. What's your answer to the why question on those?
This question is like MariaDB. It's always try, well, at least what I can see, because I do not work for MariaDB, but what I can see as a user and as a person who supports other users, it tries to satisfy different user needs. It may be kind of like in case of advanced SQL, it can be up in time with modern SQL standard and make people to use ability to write powerful analytical queries. Or it may be it's like case of like in a column store. It's in this case then we have in time when now we have many data in stored in SQL databases, relational databases. But for analytical queries and for a particular for business analytics, people prefer to use column store because they could be better optimized. And such, and before MariaDB column store, people watch happening, and they use different other databases. They copied data from a relational database from like MariaDB and copied this data, and practically had 2 copies of data, and they had to use like probably ETL software. So they to get data, they had to speak to SQL and to insert data into analytical database. They had to use a different language, and it was not easy to support these 2 copies. And column store can speak SQL. It's much easier for people who has source data, source data in SQL, and they still can use their web applications, which we use it to SQL for. S3, it's unlike, it's kind of unique feature, but at the same time, this it's maybe it goes to history of MySQL, and MySQL, not modern MySQL, but MySQL like 15 years ago, maybe even older. Then people actually, that's often like sometimes you have a web application which has a shop, and then you sell items. You have to store this sales data in order to show it. That's, for example, for taxation or for statistics and how well your enterprise, your shop behaves. Or maybe you are using like kind of something which users create text, like blog software, a social network, etc. Again, with actual data is often a small amount of data was researched. It's often inserted recently, like last month or maybe last week. But you still need data which was created earlier, and but you don't need like fast storage. You don't need to buy a better disk to access this data. You don't need to use this often. You don't need to cache it in memory. And before that, it's sometimes you don't need to update it, and so it's okay to be stored on read-only storage. And it's early days of MySQL. There was archive storage engine, which is which is used for this purpose. In version 5.1, MySQL has partitioning, and people often created like used only one partition with latest data, and other partitions were created for keeping just archives. But problem with archive and storage and with partitioning is that you still store this data in the same data directory, or if you like, well, it's sometimes possible to put into different directories. Again, it's like kind of local storage, and you have to care about this. With cloud storage, you may with S3 you can store your data in cloud storage. Actually, you have alternative. You may use it either on cloud or you can use it locally, but you can buy much cheaper storage for this read-only data, and you can have afford store of this terabytes, and sometimes even maybe nowadays is petabytes of data.
So one of the reasons there that you mentioned is related to, hey, we have this need and we've been using it in another database, so we need to do it with for migration purposes. So is that a fair situation or fair way to group these things? And you have a very short time to answer here, that some of them are like sequences for migrating applications from other places, and others have grown naturally from a need of existing MariaDB users. And you have a very short time to reply, mind you.
Yes, I think that's true, but I also think that features which are like kind of migration, like people which use different databases, that's also because people need them. That's why they use those different databases with those features.
Yep, very good concluding words. So some features are really created just because they're needed, not which makes the most sense of it all, not just to ease migration from other databases. So thank you, Sveta Sprinova. We'll listen to another presentation by you right now. So see you very soon.
Thank you.
The following presentation is by Sveta Smirnova, how to migrate from MySQL to MariaDB without tears.
Hello, today we will discuss how to migrate from MySQL to MariaDB. A little bit about myself. I'm MySQL support engineer with more than 10 years experience. Currently I work in Percona, and in Percona we support all MySQL flavors. It's first is Percona software for MySQL, and upstream MySQL Oracle's version, and MariaDB. So I work with customers who use all these products. I am author of book MySQL Troubleshooting. I have a couple of hobby projects on GitHub. I am a frequent speaker on various conferences. And here is our topics. These are topics which we will discuss today. And a little bit about MariaDB. MariaDB started as a fork of MySQL, and then it became independent product with many unique features. And at the same time, since it started as a fork, it started as fully compatible fork with MySQL. Its many important improvements are backported from MySQL. It's before it started as a fork, but now improvements get imported. So these are different code base, and you need to understand this when migrate, especially from latest versions of MySQL to latest versions to MariaDB. And first part of migration, it's initial setup. So we are taking our existing data, which was used in MySQL, and moving to MariaDB. And what happens? First, check version compatibility. For drop-in replacement, that means you can just take data dir, and without making any dump and any just stop any dump, you can start MariaDB on it. And this work for these matrix, like for latest versions of MariaDB could be started on data dir created in 5.7 directory, but MySQL version 8.0 is different because in this version MySQL introduced new data dictionary and removed table definition files with extension FRM. And therefore, since MariaDB doesn't implement this feature, it cannot just start on data dir of version 8.0. If you are migrating from version 8.0, you have to perform SQL dump and restore. So how to do drop-in replacement? So first, check version compatibility. If versions are compatible, stop MySQL server. Then install MariaDB server. Install MariaDB, and then point MariaDB to MySQL data directory, for example, in the configuration file. Then start MariaDB, and this is important part. Run a MariaDB upgrade. And if you are using old versions of MariaDB, you can run MySQL upgrade. But in 10.5, MySQL versions of such utilities, the left were just aliases for new MariaDB utilities. So just run MariaDB upgrade. And here is why. This is example of data directory taken from version 5.7. And you see most of the tables use MySum storage engine. We have data file with extension myd, and some use InnoDB storage engine with extension ibd, especially pay attention for those which are underlined in orange color. Because for MariaDB, it converts most of the tables to area storage engine with different extension, MyAD, and also it converts some InnoDB, not only some tables, but also converts some InnoDB tables to area storage engine, but not all. Like for example, you may have like engine cost is using InnoDB storage engine. At the same time, MariaDB adds additional tables like column states. This is not full output, this is not full content of data directory, but still you have idea. So like if you don't don't run MariaDB upgrade, this conversion won't happen, and MariaDB at best will return errors, and it would not be able to use some features like column states, its independent table statistics. So like once you install it, like everything runs fine. So what you need to pay attention? You need to pay attention for difference between MySQL and MariaDB. First, it's specific MariaDB features. It's like storage engine, SQL statements, options, something else. They do not exist in MySQL. You didn't use them in MySQL, so if you need, it's probably the reason why you moved to MariaDB. So just use them. So there is nothing to discuss about. Another option is specific MySQL features. It's features which exist in MySQL but do not exist in MariaDB. It's either SQL statements or some plugins. They are missed, and there is nothing to do about it. So just just don't use them. But there are features which present in both products, but they work differently, or maybe like have same functionality but a little bit different syntax. And these are our focus today, because this is actually what you would probably would like to continue using, but you would use them differently in MariaDB. And first part, what we are doing when we connect to MariaDB server, we authenticate. So first, let's discuss what is the difference between authentication for MySQL and for MariaDB. First, the initial setup, in that case, like if you are not upgrading, like just creating new server, MySQL deprecated MySQL install DB utility and removed it version 8.0 in options to use MySQL D and option initialize. But MariaDB didn't deprecate MySQL install DB and still uses it. And actually there is nothing wrong, it's nothing incompatible with it. It's just like just use this utility, and they MySQL D initialize and MySQL install DB, we are doing the same thing. Both servers, both products support authentication plugins, so you can decide how you want your users to be authenticated. But they are different in both products. In orange colors, color I underlined what is exist in both products. This is native MySQL authentication plugin, and this is socket peer credential plugin. MySQL supports default SHA-256 or caching SHA-256, which is default in 8.0. It supports clear text plugin, which is allows client to, which tells client to don't hash a password, and just like send them assist to the server. And also it has no login a plugin, which could be used, for example, for storage procedures. Then it doesn't allow this user to log in. It just can be used like for storage procedures or for events. These are not supported by MariaDB. MariaDB instead supports MySQL native password. MySQL old password actually supported by MySQL up to version 5.7 included. Its old password, which is used prior version 4.1, is deprecated and used only for when you upgrade to very old versions. MariaDB supports SHA-256 on the client side only, so it can connect to MySQL servers, but it doesn't support this plugin at the server side. Instead, it supports this plugin for secure connections, and this is for Kerberos. It supports PAM plugin, which is Percona server also has open source version of PAM plugin, and MySQL has commercial version of PAM plugin. MariaDB supports also named pipe as Unix socket, so you can connect from Unix sockets on Linux. User management SQL, like create user, alter user, etc., is the same as there is nothing changed, so you can just use it as use it in MySQL. But MariaDB supports multiple plugins per account, which MySQL doesn't, so this is kind of extension and kind of advantage. Password validation, they work similarly, but these use different underlying software. MySQL uses in version 8.0 validate password component, and before it used validate password plugin, which is now deprecated, but it both regulated by the same options. So these are like password length, there is dictionary file, it should be path to this dictionary file. It's count of numbers, count of mixed case characters, count of special characters, and policy it's could be from it's like it's medium, it could be like strict or not strict. It's you can specify it. MariaDB supports two plugins, and one is simple password checks, which checks just length of the password and checks like same case letters, digits. So it works similar to MySQL, but it has different options and has different internal implementation. And another option is crack-lib password check, which has only option it's path to the dictionary. Again, it's like it's similar to MySQL, but it's a little bit different in underlying. But you can easily adopt your password validation policies when you migrate. Password expiration works the same way, so you can just set up like expire password as it's absolutely same syntax. Now for roles, roles is again the syntax is same, but it has different storage and it has different information about where you can find information about your roles. MySQL has 6 tables which show details about roles, and store roles definitions and tables user inside MySQL database, and also MySQL role edges which connect role with a user. In case of MariaDB, you can find information about your roles again in information schema, but it has less number of tables, just 2 tables, applicable roles and enabled roles. And also they stored in MySQL database, but it's same in user table, but roles mapping is in another table called roles mapping. And what is the difference? Its difference is that's when you create a role in MySQL, when you grant some role to another user, this role is not available for the grantor. Like if you are like kind of root user and you create some role, it's not in the grant to user like Sveta. This role would not be applicable for the root user, but for MariaDB, role automatically available for the grantor, so which we can see in the previous slide. So it's like same my role, it goes to the root user who has admin option and can do something with this role, grant or revoke it. And this is also applicable to user Sveta, which doesn't have admin option and cannot administrate this role. Another like common thing which we are setting up when we migrate is replication. It's practically for my all my support experience. I saw maybe 1 or 2 installations which didn't use replication. So this is kind of something which very basic and very important to do. Replication without global transactional identifiers, it's compatible. It's
can work any way around, but again, this is not something which is recommended by MariaDB, but this is which I tested and I see it's like kind of works. But what you should pay attention for. First is data types are compatible. So like in case if it's some data type exists in MariaDB, but do not exist on MySQL or vice versa, you cannot use row-based replication. Version 8.0 adds additional complications, especially character sets, and we will discuss character sets later. And it's probably could be not trivial to create replication between 8.0 and MariaDB. For GTID, both products support GTIDs, but implementation is different. And MariaDB understands MySQL GTIDs, but MySQL does not understands MariaDB GTIDs. So only replication when MySQL is source is possible, but when MariaDB source is not possible. So like only replication from MySQL to MariaDB if you are using GTIDs is possible. For multi-threaded replications, it's supported again by both products, but concurrency control is different. For MySQL, it has option slave parallel workers. It's number of SQL threads which can run statements in parallel. It has parallel type, either database or kind of automatical logical clock. It also has bin logged transaction dependency tracking variable, which also could be used for better management of parallelization of multi-threaded replication. In MySQL or in MariaDB, its options are different. It's called number of threads called slave parallel threads. Then for domain is for multi-source replication. And what is important is parallel mode is has not like kind of database or logical clock or write set. It has either optimistic or conservative or aggressive, minimal or none. So that's mean like none. It means there is no parallel mode. Conservative it means it's most safe option, and like aggressive is less safe but most performant option. So you have probably to study and to find difference and to find which is the best for your application. Multi-source replication, it's again supported by both products, but it has slight difference of administrative statements. Like for MySQL, it's change master to master host source 1 for channel source 1. And in MariaDB, change master source 1 to master host source 1. Slave status for MySQL is default show slave status is for all channels. And if you want to see slave status just for single channel, you have to specify it. And in case if you, it also has performance schema, so you can also use this statement to query performance schema on slave status. For MariaDB, default is default connection, so it's default source. And if you want to see show slave status for all sources, you need to use show all slave status. So that's quite different, but otherwise it's works pretty similar. SQL differences. So like what is like mostly about how to work. We have like similar features, but you have to run a different SQL. So one of these is analyze, explain analyze, which is in version 8.0. So what is this? This is extension of explain statement. And explain statement by default, it doesn't execute anything. It's just estimates how optimizer will optimize the query. And in case sometimes it's telling lies, and sometimes you need it would be useful to actually execute the query and to find out which plan was created for the live query. In this case, MySQL uses option explains analyze and prints data in new tree format. It's available only in version 8.0. In MariaDB, similar feature available since a long time, but it's caused differences. So you can just like run analyze and put your statement here. And number of rows, it's actual read rows and actual filtered rows out of result set.
Explain for the running thread also works slightly differently. For this example, I saw not very useful. I used not very useful select. I just selected like something sleep which run like for 100 seconds. And for MySQL, I use syntax explain for connections where I took process list ID from the previous slide. It's 2, and I get result immediately. For MariaDB, I'm using similar syntax. It's ID and 3, and I'm selecting only 30 seconds. In this case, show explain for free, it took 25 seconds, so MariaDB kind of may sometimes explain should take longer than case of MariaDB, and even sometimes fail with log wait timeout. So this function works, but this function works certainly differently than in MySQL. Histograms and table independent statistics. MySQL support histograms in version 8.0. These are collected on demand. Histograms, it's statistics which stored independently from engine, and store data for like if you have values 1, 2, 3, 4, 5, and you have like for the like if you have like store colors, like so you have like three rows storing red color and 1000 rows storing blue color. In case if you are using indexes, you will have cardinality which is about half of the table, like 500 for both colors, which is quite not true. And for histograms, you are storing difference between like it will just like you can identify that table has only 3 rows with red color and 1000 rows with blue color. It could be useful when creating plans. MariaDB supports histograms for quite long time. It also supports kind of similar to index statistics, but engine independent way. And histograms in MariaDB, they are collected and used by default, so you do not need to have like in MySQL. You have, if you need to have histogram statistics, you need to run analyze table and run to specify statement to create these histogram statistics. In MariaDB, they are collected by default, and they are used by default. Other statistics, not histogram-based statistics, it's collected on demand, so you can you have to run analyze table, but it's used by default if it exists. Functional difference, so difference in similar functionality. JSON, first is JSON. MySQL has special data type which contains JSON kind of optimized format. It also has functions which are not available in MariaDB. MariaDB has also, like, you can also create table with JSON type, data type, but this JSON data type is mapped to long text because like MariaDB ran tests and found that JSON data type doesn't have performance advantages for MariaDB server. But when you specify JSON keyword in creating MariaDB table, this option is checking if JSON value is valid. It's automatically enabled. So like it's same as creating a table with JSON value as long text and creating check manually. And also MariaDB has functions which are not available in MySQL but available in MariaDB. But this data type thing, it creates some issues with replication. So it's for statement based, it works fine. But for row based replication, it cannot convert from MySQL JSON, cannot just replicate from MySQL JSON type to MariaDB long text type. Because these are different types, and you need to convert, like if you have source of MySQL, source is MySQL, you have to convert JSON data type to long text. Geometry extension is both uses SQL with geometry types of open this OGC consortium. This is both for MySQL and MariaDB. MySQL has slightly bigger number of functions, and I suggest you to check user manual in case if you use these functions. But otherwise, it has almost same functionality. Regular expression, both products support Unicode. MySQL support Unicode Science version 8.0.4. It uses ICU library and extended regex syntax. MariaDB supports Unicode Science version 10.5 and uses Perl compatible regular expression syntax. So these are like it's both are Unicode safe, but syntax of regular expression could be slightly different, maybe not slightly. So you need to check your regular expressions. And also MySQL has option keyword regex plug, which MariaDB doesn't have. Localization. Localization is character set. MySQL and MariaDB supports both similar set of character sets, but character set GB 18030 is available only MySQL. MariaDB has more collections, like 30 or 40 more collections than MySQL, but MariaDB supports not all MySQL collections. And this is why, for example, replication or importing dump from MySQL 8.0 has some adjustments, because default collection for UTF-8 MB for character set is not available in MariaDB. So you need to check your tables definitions and probably adjust character sets before migration. Diagnostics. For diagnostics, it's actually like I want to focus on two features. One is progress for alter table. In MySQL, it has this option in performance schema. And you may see like you are using invent stages current, invent like alter table. It's work completed, work estimated, and sometimes it goes above and just like some numbers when you cannot predict when actually the work finish. There are more stages than we are seeing on the slide, but when we are having example, it's probably like it's the stage which taken most of the time. For MariaDB, there are a few options to have progress of alter table. It's one is information schema process list is stage one. It actually has two stages, and here is progress in I believe in percents. Another option is use show process list. It's again has progress here. And third option is supporting clients. So this is either should be MariaDB command line client, or if you are using some program, you may add this support to your program. It's described in the MariaDB manual. Not all clients support this. And in this case, again, you will see just like this stage of how much alter takes. Another issue, MariaDB supports this progress not only for alter table, but also for number of other statements, such as load data in file. And again, please consult the manual, but since we are talking about migration and MySQL doesn't support progress for such statements, I do not have supporting slides. Another, like in MySQL Science latest versions, performance schema is main troubleshooting source. MariaDB does like ports it from MySQL, which it finds useful, and it doesn't port everything. So what is missed? First is tables regarding logs. These are actually existed in old version even in MySQL, but in 8.0 it was moved to performance schema with adding additional columns. It's data log weights and data logs. In MariaDB, they are available for storage engines which support such tables. These are InnoDB, TokuDB, and MyRox storage engines. So like it's InnoDB logs, InnoDB log weights, and same for TokuDB and same for MyRox. Variables, there is no table called global variables in MariaDB, but they are available in information schema. Same for session variables. Variables info with information of variables available in information schema system variables table. And practically MariaDB has maybe even more information on variables than MySQL here. Variables by thread is not available in MariaDB. For replication tables, they are again not available in MariaDB. In MariaDB, use show slave status to get this information. Error summary tables, which are added in version 8.0, also not available in MariaDB, and there is no equivalent. Statement histograms, they are not related to optimizer histograms, which we discussed before, but this about histograms about how frequent such statement executes or how long it takes. It's again, they are not available. It's a kind of performance statistics on SQL statements. These are not available in MariaDB. User-defined functions, they exist in MySQL.func table in the MySQL database. Log status, which contains information about binary log and LSN of NADB storage engine, is again, there is no such table in MariaDB, but it could be obtained by show master status and could be obtained from show NADB status information about LSN, though it's not such convenient when using one table. So a conclusion. So initial upgrade is straightforward. Just take data directory, unless you are using 8.0, MySQL 8.0, and just point MariaDB server to there and run MariaDB upgrade, and you are done. Feature difference are mostly easily solvable. So you just like either a little change SQL syntax, or maybe adjust your application a bit, but it's very easy. MariaDB has options which simplify migration, like you cannot replicate from MySQL source server even using global transaction identifier, so you can safely migrate to MariaDB to explore all MariaDB advantages. Unfortunately, it would not be easy to migrate back to MySQL, so if you are considering option to migrate back, please do not migrate everything, but because MySQL is not so friendly for MariaDB specific options. This is slides about more details. It's mostly points to user manuals for MariaDB for specific topics which we discussed. These slides will be available online after the conference, so you can download, and these all are clickable link. But these are also QR codes. If you are curious now, you can just use your mobile phone that follow links using QR codes. And I put here links so you can easily like use them like reference when you are migrating, so you can quickly find out what needs to be adjusted in your application. Thank you. This information about my where you can find me online, and the slides also will be at SlideShare a few dates after the conference. Thank you.
Thank you again, and hello again, Sveta Smirnova in Alanya, Turkey.
Thank you, and hello.
So, weeping and tears, and when migrating from MySQL to MariaDB. So, what would be? I think there are several levels of reasons to cry. The most serious reason would probably be that you would need to do a MySQL dump or MariaDB dump of your data. What's the worst case scenario here of causing tears?
Worst case scenario is migrating from MySQL 8.0, because in that case you have to do that MySQL dump or MariaDB dump. But it's not for other versions. It's like you see on like one of my first slides with a table. You don't need to do it. You can just uninstall your MySQL server and start and install MariaDB server and start it and run MariaDB upgrade or MySQL upgrade. But for 8.0, the story is different, and you have to make dump restore, because MySQL 8.0 has new data dictionary, which is not supported by MariaDB. And also, that's very interesting. That's collations. MariaDB supports way too much more collations than MySQL, but it doesn't support few which MySQL has. And practically default collation for UTF-8 character set in 8.0. So like even if you are doing dump, you either have to first change your collation for all your tables from default to something which supported by MariaDB, or you should manually edit your dump file and change those collations mentions to something which MariaDB supports. Fortunately, this is not resource-consuming task, because collation is only sorted order. It's not how data is stored. It's not same as changing character set, but still you have to do some either manual work or create some script to make this migration.
So the weeping there is lots of manual work, and specifically with migrating off MySQL 8. But then the happy scenario with very little tiers is that when you're prior to MySQL 8, you could also often just migrate to MariaDB as easy as you would upgrade to another MySQL prior to MySQL 8. Is that the case?
Yes, that's true. That's true.
So, so that means that one of the reasons for the tiers is backward incompatibility. If I understand it correctly, it's not easy if you for some reason are unhappy with the new version of MySQL 8, you cannot go back with the same to an earlier release without the dump, and even that there are some borderlines within MySQL 8 where you might need such a MySQL dump, totally irrespective of MariaDB. Is that true?
Yes, that's also true. It's if you are going to downgrade from 8.0 and even between minor versions, you have probably used dump and restore.
Okay, so that was the sort of, if you talk about individual releases, then a problem area for causing some pain is the global transaction ID. So what's sort of the top level conclusion on that one?
The global transaction IDs, they are implemented completely differently. It's like, I personally say I like MariaDB implementation because they are more human readable and you can understand what does it mean. It's not something cryptic. But never mind, MySQL cannot understand MariaDB GTIDs. And while MariaDB can understand MySQL GTIDs, it still cannot write them, it cannot imitate them, and if there is no option like so that's you can only you cannot have like if you have replication set up and some master is you can only replicate from MySQL to MariaDB. You cannot put MariaDB in between and replicate from MySQL if you from MariaDB to MySQL if you want to use global transaction identifiers. And this is a really cool feature, global transaction identifiers, because this we add additional level of safety, and so that's no transaction applied twice. So that would be very pity to remove it from your application setup because to have this compatibility.
So if I understand you correctly, global transaction IDs work in both databases, but you need to migrate completely then because you can't mix the two in the same replication setup.
Yes. It's only like temporarily you can replicate from MySQL to MariaDB, but not vice versa. It's another pain with replication is incompatibility if data format. Like for example, if you are using JSON data type, which is supported by MySQL but not supported by MariaDB, or if you're using inet 6 data type, which is supported by MariaDB, not supported by MySQL, you cannot have use row-based replication. Statement-based would work, but again, row-based is more safe because it's replicate only changes made to the table, and doesn't replicate statement, which could be executed differently on source and replica servers.
So you've now mentioned the data format changes of individual fields. Then you said the entire database is stored differently in MySQL 8, and there are several versions of it. And then you mentioned global transaction IDs. Any other top conclusions of what could cause these fears?
Well, it's just one note. It's MySQL is not MySQL 8.0 is not completely different, but it's stored completely different data dictionary. It's how like watches was stored in the DB shared table space, and also watches how stored MySQL database where your user account created. But speaking about pains, of course, when you migrate from one version to another, like if you migrate to MariaDB, you will miss some MySQL features, but you probably migrate to use some other MariaDB features, and this is the reason why you migrate. So probably that would be not only tears of sadness, but also tears of happiness.
Tears of joy, exactly. Great conclusions. Thank you, Sveta Smirnova, for saving us some sad tears and hopefully giving us some happy tears. Thank you.
Thank you.
The next presenter is from MariaDB Corporation, Richard Bensley. SQL mode equals ludicrous.
Hello everybody, my name is Richard Bensley and I work for MariaDB. I'm actually a software developer. I'm working on the monitoring team for SkySQL, our new cloud platform. But I've been invited to talk about my little talk that I've entitled SQL mode equals ludicrous. I've got about half an hour with you all just to cover a couple of scenarios of how I've used MariaDB in production environments in probably the most nonsensical ways possible, or at least how I've used some of the more interesting underlying features that I've previously found as a DBA to really help me out in production environments, not just in production has failed or something has gone wrong, but also how I've kind of used a few little things in system design, which I've had to like design, create, maintain, which has actually helped our environment. So I hope you enjoy it, and we're going to have some fun now. I'm gonna kick off with my first example using my favorite tool, the connect engine on MariaDB. I was a very early adopter of MariaDB 10 when it came out, and the connect engine was one of my absolute favorites. I was working in a mixed database environment, so I jumped onto the ODBC connector very quickly to start querying other databases, not just MariaDB, from afar. I started using SQL from a database to query other databases, and I'd use it for reporting, materialize use, data warehousing, ETL, ELT, all sorts. The Connect engine documentation is vast, and it supports more than one table type, not just MariaDB, not just ODBC, but all kinds of table types you can start using. And one stood out to me in particular, which is the ini table type, which also happens to be very similar to the server config file format. I thought this could be quite interesting. How can I use this? The ini table type itself is what's called an outward table. So that means when you create the table definition inside MariaDB using the Connect engine, you have to define the table name. And I did actually have a use case for this. If I just get back to my terminal, there we go. I've got Linux, MariaDB 5, 10.5, not 5, that'd be very, very old, 10.5 running on Linux. I've got a little custom environment here set up in a way that kind of resembles some of the production environments that I encountered before. And it'll kind of take me through these scenarios. So I had this scenario where MariaDB was new to us, MariaDB 10 was new to us, and so was Linux. We're still mostly on Unix at the time. Still, after 2010, there's still plenty of Unix shops out there. And whilst the sysadmins and DevOps trying to figure out what the DBAs should do now, where the database should live, They just gave us a directory and said, you own this, you run everything as this user, and you've got some network mounts. I said, that's fine. We can just customize everything like that. In this case, we had a /MountDB kind of looking thing, and I just kept everything in one place. I could demonstrate that inside the server config. Quite simple. Just foreseeing the socket connection for some clients in case they need it, because the default Unix socket authentication is fantastic, but I do just have to tell it it's not a default location, as I have customized it to be inside this directory. My Linux user is Vagrant, as I'm using Vagrant in VirtualBox to run this environment. So I'm running the database as this user on this system, not using the typical MySQL servers account. So in theory, the DBA owns this environment, the files, the data directory, everything involved. And I've got just about everything I need here for the examples I'm going to be talking about today, including the Connect engine. So in that scenario as well, like you can see, I've got plugin load HA Connect, so it will load on startup. And if I just go to the server now, show engines, I've got the Connect engine listed there. There we go. That's fantastic. So I had an environment where I could edit a lot of the server configs. Well, we could edit a lot within directories, but we actually packaged this stuff and we had to move it away. So we didn't always have SSH access to a box. We just package the database up with everything we need in a SQL, baseline schemas. We could get it up and online from far away. Then we could connect in, perhaps set replication properties if we needed any, and whatever else we need to customize. So we didn't always have file system access. This is very important. We own these data directories, we own these databases, but we didn't always have file system access. Here, enter the Connect engine any table type. So we normally have, I think most people have probably seen this in their environments. They've got a schema or a database called DBA. In there is all your DBA tricks. And I've just got one table in here today called CNF. I'm also going to show you how I made that with a show create table, CNF, -g. Here we go. So I've got quite a simple table definition, and this actually matches the config file format that I showed you previously. That the database that MariaDB is running, and it owns that file. It's got permissions for that file, so it's using the same user. And it's an outward table, so I've got a file name defined. The engine is connect, and of course my table type is ini. So let's have a look at what this table actually looks like. Let's select star from CNF. It's not a huge table. There we go. There's that ini file. There's that server config as a table. Let's update it. Actually, I've got a copy paster over here. I'll just grab this, run that. Oh, and I included the end of line as well. So it ran it for me. That's great. Just to go over what I did, I updated the table and I set the variable value for the log output. For those that do or don't know, the log output changes where the slow query log and the general log goes. So it defaults to file, and I did say file inside the config. But you can also set the variable value to be table, and they appear inside the system schema. So I was very specific. So with variable value, with the variable name equals log output, and the section equals MySQL D. So it's quite handy that you can see my client section is up there. I said I had to specify the socket for my clients. And previously the log output was set to file, and I just updated it to table. Let's select star from CNF. Let's have a quick look. Ooh, it worked. I just updated the server config from the SQL prompt, potentially remotely. This is extremely dangerous, but it's a lot of fun and could be quite useful in some scenarios. And I definitely found it useful where they kind of set a database up for me. They want me to connect in and test things, but things aren't quite right. If I wanted to get something changed, it might take an hour, it might take a day, might have to wait to a change management window before I can actually make that change. Some things like this are a little innocuous. Of course, if you have a change management process, I'd stick to the change management process. But it was a nice little addition, and for various other table types like JSON or CSV, it was nice to have another method to connect in, edit and read files, particularly as DBA, particularly in restricted environments. So that was quite fun. I was going to set that back. I was going to update that back to a file. I don't want any surprises at the moment. I'm just going to shut down the instance as well and maybe restart that and make sure it comes back. Do not want a dying instance during a presentation. That would be terrible. Show schemas. Are we there? Show process list. We're up and running. Select log output back to file. That's fine. Okay, so that was quite fun. And that in the same place, again, working with restricted access and having to go through jump hosts and things to gain access to production instances, we had a production instance which failed. And I like to call this little scenario the backup battle royale. So we had a failing instance and everyone was looking at it. I myself had a remote SQL shell logged in, similar to the very dangerous Connect Engine session I had open there. So I could actually poke around the database to see what was going on. There was minimal database activity, which was good, but the rest of the system was having lots of problems. And this system was going down. The sysadmins told us, this system is going to go down, and if it doesn't, we're going to take it down. You need to put your stuff elsewhere. So, well, okay, we could do that, but the backups were from this morning, and they were already too old. The rest of the business was adamant we needed up-to-date data. So, okay, we can't get the bin logs. When they tear that system down, the binary logs are going to go for whatever reason. I was the last user left alive. I had my SQL session, but we also had one extra thing, which was the backup. Where we put the backups was a network mount, and the database could write to it. And I whipped out my favorite tool, Outfiles. I'm sure people have used Outfiles on and off over the years. It's by far one of my favorites. It's so simple. Along the vein of Connect Engine, I can just interact with the disk as well as remote things. And I could put files, I could just select data and put on a disk. The default format is tab separated, so I'm going to use the TSV as my extension when I start working with things in a moment. And I've always found this super useful, not just in some odd backup restore scenarios like this, but also just in, lots of people have probably used it for ETL, ELT, for loading in and out of column store in particular, or another system, or just doing an archive backup, export into CSV, TSV, upload to a bucket like S3. However, in this scenario, I was trying to get up-to-date data from a failing system. I've got a database in here called Jam, which is a fictional jam factory where you can order jam from. And I've got some tables. Let's have a look at some tables. There we go. Let's start from T_jam orders. Oh, well, it's 10,000 rows. I was going to do a count. There we go. Count 10,000. Don't want to see every single row. That'd be terrible. Good thing there wasn't a billion rows. Good thing this wasn't column store. That'd have been many more rows. I'm just going to create, for this example, I'm just going to create and load a table locally from disk using the in-file, out-file interface. So I'm going to select everything from the jam orders table and put it into another table. So in my actual scenario, these were remote databases. So what I'd export from one database and put it somewhere else. So we can get your database up and running somewhere else. Give me 20, 30 minutes and I'll get it done. It wasn't a huge database, but it's still important data. So I'm just going to create a new table like that table. And I'm going to call this new table, new table. Next, I'm going to select star from jam.t_jam orders into outfile. This is where the magic happens, and I'm going to specify a path of where I'm just going to write to temp. Everyone can write to temp. That's very handy. I'll call it jam orders dump.tsv. There we go. And I've exported 10,000 rows. Let's have a quick look at that on disk. WC-L temp jam orders dump.tsv, 10,000 rows. So if I just tail the last 10 lines, You'll see that this is just this is a row per line inside the file. You see it's tab separated. That's the default format. You can specify more options, as you can see in the documentation. Well worth reading. You can specify the delimiters and what it's terminated by. Particularly handy if you've got perhaps some funky characters going on inside your database tables. But we don't for this scenario. Pretty simple. Date times integers. Nice and easy. I'm just going to go back to the Jam database. I'm just going to select count star from new table. Nothing in there, that's fine. Now I'm going to load that table using the exported data. Load data in file, and it was /temp/ jam orders dump.tsv into table jam.new table. Genius naming. Load data in file into table. There we go. I'm just going to select from that table again. Select count star from new table. There we go. Show create. New table. There we go. Just the regular InnoDB table, and we've exported the data to disk and loaded it from disk. So in my scenario, that was a network mount, and that was a lifesaver. We kept all the schemas inside version control, and I always thought if that wasn't there, my last-ditch effort would have been to clear my terminal, did a show create for everything, every store procedure function, every table, and put that somewhere else, then just do the load data. Thankfully, we did have the schemas and all the database objects inside version control, so I could quickly get that up to date, restore the backup, then just load the difference. For a couple of tables, I just dumped and loaded everything. For some, I loaded the difference, and that was a lifesaver. That made a big difference. I'm just going to drop that table now. Drop table, new table. I'll get back to where I need to be for the next little mission. Oh, just one caveat for in-file, out-file. The only caveat which you might encounter when using this is so that file already exists, the out file I created. So if I select star from jam orders into that same file, the file already exists. That's the only caveat with the in-file, out-file interface. If you're creating files, you do need to make sure that what you created doesn't exist before you do it again. So it's a shame you can't overwrite it. I guess it's kind of a security feature. And in better practices, I'd script this and I'd append a timestamp or something to the end of the file name. So it's a little bit more descriptive other than just this. But for an example, it's fine. Now I can run it and it's fine. Okay, let's go remove that file again. All right, let's clear screen and go on to the next example. Casual conversation one morning with a colleague. Somewhere, someplace, sometime. They were developing a new system, and MariaDB was now the new tool of choice for everyone, which is good. Did our jobs as DBAs. We canvassed development globally, and we got them convinced, and they were all very happy, and they'd already seen some of these kind of other things we were doing, so everything was working very well. Until the conversation came up, we've got something new. But if it gets big, how do we scale it? I said, well, don't worry about it for now. I said, let's just get binary logging enabled, and then when you're ready, we'll come do a bit more consultancy with you, and just set the bin log format to row. That's all we're kind of looking for, and just make sure the expiry is longer than the restore time. We said, well, what does that mean? So you've got an option to set the binary log expiry. So if it takes a day to restore your database, you need at least 2 days worth of binary logs. So if that restore doesn't happen, you're going to need to, if you've got another server downstream or upstream that's serving requests, and they're kind of running out of time, you need to make sure your backups and your binary logs are all in sync together. So you back up and restore to a certain point, then you might use your binary logs to do a point-in-time recovery to restore up until it's absolutely necessary. For some people, just a daily backup and restore is fine. But for a lot of customers, the scenario is a bit like that in-file, out-file scenario. Bin logs weren't available. We couldn't use a backup. It was too old. Or the backup was up to a point. So I essentially did a point-and-store recovery with TSV files, just plain text files. And it did kind of work. In a normal scenario, you'd use binary logs. It's a much more robust scenario, robust solution. As I say, take a lot of this with a grain of salt, but I had a lot of fun in production with MariaDB, and we solved a lot of neat problems. So anyway, I don't hear from this team for a little while, and suddenly they call up and say that the customer's using this instance. Okay, how can we help? Well, we need to dump and restore it to another database, but we don't have any backups or anything. And in fact, we kind of lost access to this instance. It broke, and they need to restore it. That's essentially it broke, and we need help. But they didn't have any backups. However, they didn't actually set a binary log expiration. Because they didn't have any backups, they didn't have something to set it to. They said, "Well, we'll just keep it forever." I said, "That's even better. That's fantastic. Don't worry about the backups. We'll get you up and running on a new box, and we'll apply our DBA standard to it. So there's monitoring and backups and point-in-time recovery and alerts, and we'll just restore the entire database using the binary logs." They thought that was magic. I'm going to quickly whip through this example. I'm going to use my Jam database again. I'm just going to show you there's nothing up my sleeve. I've got some different queries just to make sure I've got what I need. So if I select count a sum from the orders table, there we go, a sum of just about 1 million orders. And now I'm going to just delete everything from these tables. Just do a quick sum again. Okay, I'm just going to look at my existing binary logs. Now I'm just going to wipe out these binary logs. I'm just going to reload this database for an example. So if I do a quick select star again, so these tables are now empty, and it's a fresh database, if you like. I've got no more binary logs. If I show binary logs again, we're back to nothing. Okay, so I'm going to emulate the scenario that we are in just by using a little Python script I put together to populate the Jam database. So I'm just going to load that with data. So in theory, they started a new instance, they started loading data, they were creating tables, creating schemas and objects and all these kind of things. And while they didn't have a backup, they did have the entire binary log history. So in my case, this is only going to be inside one file. We started at 325 bytes on binlog 00001. If we just go have a quick look at the database and show binary logs, we'll see that the position counter has now moved on because we have loaded data. Now, just to have some fun, I'm going to, again, I'm just going to flush logs to move me along one log. So now we should have 2 binary logs. There we go. So now everything I do new will be recorded inside this next log. Easy peasy. And in this new log, I'm going to delete everything again. Oops, let's use Jam, and let's just delete everything again. So if I run my quantifier, there we go, aggregate function, we're back to 0, we're back to no rows. But that's okay, because I know there's one binary log there with all the data inside it. So I'm just going to go to db/data. And I am going to use the binary log command to replay the binary log against the instance. I'm just going to copy paste. I'll talk through it rather than copy pasting it. Of course, everyone noticed the new binary names are available. So instead of using MySQL binlog, I'm using MariaDB binlog. The binlog I want is 001. It's the first one. I'm only going to replay one set of database events from the Jam database into the instance, into the database, Jam. I'm just going to let that process. Perhaps I can see what's going on inside my show process list. There we go. So that's going to go through. But, oh, we're done. It was too quick. Too quick. Okay. -A, Jam. Let's go back to the database. So we had no orders before. Let's do a quick quantity on there. There we go. Fantastic. Who doesn't love binary logs? Managed to restore, dump and restore the entire database using binary logs. Very handy. Right. Hope you enjoyed that one. I'm going to cover one more scenario before I leave you all. I think most developers, DBAs, have come across this scenario before where the first thing, I've heard the story so many times, you join as a new DBA, you don't know the circumstances of you joining or the previous team or people leaving, but you've got like a database, or perhaps you've just been hired for a particular set of databases they've got problems with, and the first thing you do is lock out every single developer. Well, I did need to do this, but I didn't need to be so. I didn't need such a sort of blanket ban of all developers. What I had to actually do was lock them out of different regions, and for reasons I can't disclose, the servers in each region would be rolled over. So the master or the primary would change to each region as the world turned and the sun rose for another day and somewhere else. The new primary would move. But it also meant if developers were doing overtime in their region beyond 5-6 p.m., they could stay inside their own region, but they could not log into the new region. And we did that on purpose, so they wouldn't fiddle with the current primary. So to fix this, I came up with a solution which I found in the documentation years ago. I'd seen this around init connect and init file. Init file is a server variable you can put in there, pointed towards a file full of statements, and that's SQL that can run during a server startup. Init connect covers SQL, which is executed when any user connects. This is terrifying, and I use this in production to control user access, and I'll show you what I mean. Some of you may have seen inside my config file before, db.my.cnf. I've got a little line up here, init connect call auth check user account. So the connect SQL for me is a store procedure which is run. Let's go and have a look at that. So I've got a database called auth, and this is where I stored everything related to this region lockout mechanism. I just do show create procedure check user. I think it should be called check user access. There we go. I just three variables. Just who is the current user connecting. An integer just for allowed, 1 or 0. 1 is allowed, 0 is not. The process ID, which is the user's current process ID. And you'll see in these, I just set the current user to be the current user from the user function. And I select allowed from a table where username equals current user into the allowed variable. And then I just grab the connection ID into vProcess ID. And if allowed is 0, then this select statement shouldn't actually render anywhere at all, but kill process ID. Just there for just to be a bit more clear. And I just kill the user's process ID if allowed equals 0. So let's select star from users. So everything except my jam user, root user, test user, vagrant. I've got one user here, test user, who's a bit of a troublemaker. Is not allowed to log into this particular region. I used a non-replicated table to maintain these tables in each region, and it worked well. So if I try and log in as this user to this database, it's going to read from this table using the store procedure, and it won't let me in. MariaDB -u is test user. The password is trouble. Okay, I'm in. It may look like I'm in, but I'm not in. Do a quick show schemas, for example. Connection aborted. That's it. Init connect command failed. We're done. We're done. No access. Okay. Well, let's flip that on its head. Let's set allowed for the auth user. There we go. Select star from users again. There we go. So all users are now allowed. And let's try connecting again. If I test user, we'll do a show schemas. Now we're in. Now we can use MySQL and select star from user because we are a troublemaker. So that was a very simple mechanism. Do I recommend it? No. It takes a lot to maintain that kind of scenario. But if you're comfortable with this kind of like change management and testing, always test, then you'll probably find it a very useful feature. And you could do all kinds of things. The init file I've used quite a lot in container scenarios. So a new server comes up in a container and I just want it to run some extra SQL. Perhaps have a container that's kind of more ready to go, rather than having to load a container as an afterthought. I can have a Docker file or something which actually loads a database on startup. It's probably one of the most dangerous but more interesting variables I've come across, features I've come across. I hope you have some fun. I hope you kind of come away from this thinking, I'm not doing any of this in production ever. That's good. If you come away from this thinking, I'm going to do some of this in production, that's also good. I highly recommend experimenting with the Connect engine, what you can and can't get in and out. The in-file, out-file interface has been an absolute lifesaver for me. Just get data out, put it somewhere else, bring new data in. Script it, automate it. Just remember, you can't overwrite the files. The init file has been a lot of fun for me. And of course, become familiar with replaying bin logs. You can do a lot of magical things. And in that particular scenario, I just restored one database from the binary logs all the way from scratch. And it worked great. And they were really happy. Thank you for listening to me. And I hope you enjoyed the rest of the Serverfest.
Thank you, Richard Bensley, calling into virtual New York from physical Norwich, UK.
Hello, Kai. Hello, New York. And hello, MariaDB Serverfest. Hope you're all well.
Yes, I think we are. So you work for the MariaDB Corporation. Does that mean that this is a rare encounter with the community, or what type of community exposure do you get?
Oh, not at all. When I started back as a young IT person, I cut my teeth on the lamp stack back in 2003. And I dare say I owe my career success to the community at large. I moved to London and all those years ago. I'm now back home, but I joined user groups, Perl user groups, Linux user groups, PHP, Python meetups, and of course at the time MySQL. And I was there as the MariaDB user groups kicked off as well. And you'll probably find Federico is at the conference, used to run our London one, and Louisa, one of our sales ladies, she runs our MariaDB London one as well. Highly been involved for years.
Good. Okay, so looking at the ludicrous things and fun things that you were saying there, let's say that one starts using some of these because they were interesting and productive as well. Doesn't that mean a lot of complexity for the organization that should deal with it? How do you deal with that complexity?
Yeah, it is a lot of complexity. I highly recommend everyone reads the manual and learn just what all these crazy things are you can do inside a database and start experimenting. Once you've experimented with it, document and test it. I can't live, and I would never work without a change management system. I think this is very important. It doesn't matter how you do it. You can work in sprints. You could just have weekly, bi-weekly meetings, but as long as you have an opportunity to document, test, communicate and discuss changes among teams, you can introduce the world to your teams to a whole new world of complexity and new opportunities, as long as you communicate it and show them the advantages. And likewise, they might start weighing in on it as well.
Out of the ludicrous things, it seems like you were considering the triggers to be particularly ludicrous. Do you think one should write a book, Triggers Considered Evil, much like the go-to statement?
No, I think anything can be good. If anything can be used for good, but then of course anything can be used for evil. I think anything bad is just something that's misunderstood or not communicated. Once you get your head around, or you learn what's there, or someone has taken. Perhaps you read the documentation which someone has provided to you, or the complexity of the system that already exists. So don't be afraid. Don't be scared. It's all good. Be free and talk to each other and learn about the crazy things everyone's installed.
So I'm trying to map what you were saying to some of the other key topics here at the MariaDB Server Fest. So one theme of that has been migration in general. So what's your take on migration?
I've done a lot of migration in my over my career. Of course, I started with the MySQL MariaDB hop. That was a pretty natural one for a lot of us here. During that time, I was also doing Oracle to MariaDB. I did Sybase ASE to MariaDB, a bit of Microsoft SQL to MariaDB, and I jumped on that MariaDB 10 bandwagon at the start. And I remember I was once emailed a copy of the MaxScale source code to compile on Solaris, just because I had to start going somewhere. Multi-source replication, the Connect engine, MaxScale. I started throwing all this stuff into my environment, and they'd start matching up with other legacy products I had, like Sybase ASE replicator, which is a great product, but it's so old now. Redgate, it's great, but it's like trying to push a dinosaur, just trying to poke a dinosaur until it does what you tell it to do. But you just put up MaxScale multi-source replication and the Connect engine in front of any kind of crazy problem, and I just kind of smooth over any issue. Yeah, I've done a lot of migrations with MariaDB, and I'll keep doing them.
So one of the other key topics related specifically to migration here is people have expressed opinions on MySQL 8, and the previous presenter here, Sveta Smirnova, said that that's one particularly tears inducing type of migration, and not tears necessarily of happiness, at least when when you are migrating. So what's your take on MySQL 8?
Not only was I an early MariaDB adopter, I was an early Python adopter. And in fact, I did a Python talk for OpenWorks last year. So I've always tried to have a data platform agnostic approach to my data workflows. So now I've got my own MariaDB Python connector. That definitely helps a lot. But that's one tool in many tools in my chest. After that, look at your schemas and look at your data. There will be some surprises in there. There's things that will and won't work. You'll be surprised by some things which don't work as they come across. But you just need to take your time and look at it and try it. Just start with something simple. Do a schema dump and load it somewhere else. Go through all the type issues, errors, look all the foreign keys constraints where your auto increments are happening. Then look at your functions and stored procedures. Is there any plugins, any proprietary plugins that you've had dependencies on? I've had to deal with in-house written defined functions in a variety of languages on different platforms, so they've had to be ported over as well. And it takes time, but it's possible. If you do happen to do just a dump and load and it works, well done. That's a great success. But just because it worked smoothly doesn't mean it doesn't need testing. It's not impossible. And why not do the old-fashioned way and just set up replication primary to a new replica from one platform to another, see what happens. You can probably start adding conditions and rules to handle the errors that are coming up, if any at all. And the Connect engine has been a great one for me as well to handle migrations, not just from MySQL, but also from other legacy platforms using the ODBC connector.
Did you have a look at the Connect presentation by Federico? I
have, yeah, fantastic. Watched it yesterday after a little while after my talk. It was great. I'm glad to see Connect engine getting more love. It was one of my favorite early features. It's superb. It solves a great problem for me. One scenario I had with it was user access. I always tell this story. We had a legacy system which making changes on it was very difficult. So if we had to add a user, we had to add roles and permissions. We had to go through a long change management process, which is very good. We could track it. But the same process we had in MariaDB took only a few days. We just had to check and just make sure everyone, can this person have access? Let's check the accesses, hand over the access. That took 2 weeks on the old system. It took about 2 days in MariaDB. That's just because of our process. But I actually gave them an access to a MariaDB instance, which I connect out to the legacy system. So we could still pull all this data from the legacy system without making changes to it. And now, of course, we're benefiting from even more things like password expiry and non-simple passwords. It was a great feature for us. I love the Connect engine.
So here at the MariaDB Server Fest, we've had lots of interactivity through Zulip chat, and you got questions already yesterday in the Paris incarnation of your talks, and you've got some more today. So you've got 1 minute to tell us the gold nuggets. Any gold nuggets amongst the questions?
I think people Mr. DB himself, Marco, asked you about the null coming up in the sum quantity, and we just had a brief discussion. Like, I think that's actually the SQL standard, Marco. So that was quite interesting. Aggregate functions are something which come up a lot, and of course now we've got column store integrated. We can blow through aggregate data problems. What used to take me 20 minutes to do a query in InnoDB takes me 0.2 seconds in column store. So aggregate query functions are always. I wasn't expecting questions on that. Hopefully, I left people a little bit bewildered, thinking, "Oh, there's all kind of mad things I can do." Init file has helped me. Helps you greatly reduce the complexity in setting up containers. Anyone that's made Docker files before, generally you've got to add a layer or something on top of it, or start having some onerous bash scripts to start populating a container. There we did.
Great ludicrous features. Hey, fun talk, productive talk, and really insightful comments. So thank you, Richard Bensley.
Thank you, everybody, and enjoy the rest of the conference, and enjoy the rest of your days.
We will. And now we will have an optimizer trace walkthrough by Sergey Petrunya of MariaDB Corporation.
My name is Sergey Petrunya, and this is the optimizer trace walkthrough. Today we'll cover everything about the optimizer trace. So, optimizer trace, it's actually not a new feature. The initial prototype existed before MariaDB existed. It was initially released in MySQL 5.6, and the first release in MariaDB was 10.4 last year. After that we have added more tracing, got some experience of using it. So I think now it would be a good time to look at what optimizer trace and how we can use it. So before we discuss the specifics, let's discuss the goals. The goal of the optimizer trace is to show in details about what goes on in the optimizer. Typically the workflow goes like this. We get the SQL statement, it is optimized, then one can see the query plan if explained, then it is executed, and analyze for statements feature can be used to get information about that. But the optimization process has been fairly opaque, and now optimizer trace is used to provide details about what goes on here. And there is a lot. There are query writes, values, for example, view merging, there is where clause analysis, search for query plan, finally query plan refinement. So if you have details about what goes on there, it allows you to answer questions. The most typical question is like why certain query plan is not chosen. If you have added an index and it's not being used without optimizer trace, it can be very hard to answer the question about why is this index not used. The second very common use case is why are query plans different across database instances. This is a fairly common question where somebody is upgrading from one database version to the other, or is just setting up another instance, and it has of course slightly different statistics because statistics depends on the data layout, or there are some minor DDL changes. It's like a column has now different collation. It was nullable and now it's not null, or vice versa. And these changes seem irrelevant, but one cannot tell with 100% certainty. And without optimizer trace, one had to just manually inspect all of the parts of the environment and try to guess why the query plans are different. While with the trace, you can just get trace on the old instance, trace on the new instance, and then see what the difference is. And this is much more efficient. Finally, the trace makes it easy to ask for help or report an issue to the development team. Because having an optimizer issue and query optimization issue while uploading your whole data set is not always possible. It can be too large, or it can contain some sensitive data. Typically, you can provide explain or table definitions, but these are not always sufficient. While the trace is of reasonable size, it is also a text document, so you can view it and remove any sensitive information from it, and then submit it asking for help, or even if you think it's a bug and optimizer, reporting it to the development team. So let's look at how one uses the optimizer trace. How does one get the optimizer trace? This is fairly easy. You just set this optimizer trace to 1, which enables saving the traces. Then you run your query. And after that, you do select star from information scheme optimizer trace. And one of the columns you get is the trace, which is a really long document with the trace. The traces are stored in memory. You can use only the trace for your session and only one last trace stored. So you need to do select star from optimizer trace immediately after your query. A query can be select it's typically better to use explain and pretty much any statement that can have a query plan. So optimizer trace contents, it is a huge JSON document. Basic idea is that it's a log of all actions done by the optimizer. Now I would like to say all actions and that you can see everything that optimizer did to your query, but unfortunately this isn't the case. The optimizer does a lot of things and not everything is traced yet. But I think we have a good subset of all actions, so all of important or typically like relevant actions are already printed, but don't expect to be it to be 100% description of what is your query. So why is it JSON? Well, JSON has two properties. First, it's human readable. It's easy to extend. So we can add more tracing as we go. The second is the machine readable. By that I mean that you can use JSON processing function to extract part of the trace. The most important one is a JSON extract, which gets the JSON document as the first argument, and then you can give it a JSON path expression to what you are interested in. And the output of JSON extract is JSON document, which we can pass to JSON detailed, which will print the JSON. So this way you can get a piece of optimizer trace, and optimizer trace is typically quite large. So it's quite useful to be able to get a small subset of it, and you don't need to resort to some crazy regress with grep. In case somebody are not familiar or don't have a clear idea what JSON is, here is one slide about JSON. JSON is a very simple simple language. Basically, everything in JSON is value. A value is string in quotes, number, true, false, null. It can also be an object or an array. So array is input in square brackets, and it is a comma separated list of values. Now, values do not have to be of the same type. There is no data types, so you can start an array with string, then continue with number, then add a nested array, an object, and so forth. Members of the object is similar to array, but in the object the members are named. Here there's the first object with name, and then again the value, which can be anything, and so on. Typically, the names of different members of an object do not overlap, and this is the case for the trace. Okay, so let's look at what is trace contents and how to interpret. Before we do that, some generic background information on query processing and SQL databases. It starts with an SQL statement, then there is a process called parsing, after which there is a parse tree, which is basically what comes into your mind when you look at the query yourself. Then there is a process called name resolution, which finds for each reference to table or view, which finds which table in the database it is. So what is the column names, what are the column data types. So if you have column 1 equals column 2, which data type would be used for perform the comparison, and so forth. So this parse tree with resolved names, there is no established name for it, let's call it parsed query. Then there is query optimization, which comes up with a plan to execute the query. You get the query plan as a result, and then you execute. So optimizer trace is primarily targeted at query optimization, but it covers a bit of name resolution because some optimizations, some rewrites were traditionally done in MySQL and MariaDB early there. They are not large, but still you will see some name resolution parts. And for the same reason, it covers a bit of execution, although it's mostly in MySQL version of optimizer trace, not in MariaDB. But still, what you can see in the trace, you will see for name resolution, you will see join preparation member, which lists things which are basically done at name resolution phase. And one other thing that is not done is that just first it prints the query. And then I think there is attempts to merge view, and some other initial rewrites can be found there. And you can also see there is a select ID equals 1, so this is done for the top level select. Then join optimization. This is the biggest element typically, and there are a lot of things here. And finally, there is join execution element, which is generated when it is executed. As we see here, that this is all for select ID equals 1. This is because each select is optimized separately. Well, there are exceptions to that. The select can be merged to its parent select, it can be converted to semi-join, and so forth. And then for each select, the optimization phase is shown in the diagram. Although there is some exceptions, but the general workflow is that for each select, we first do rewrites and transformations. Then we collect table information and table statistics. This is like preparing for the game. Then there is a main game join order choice. This is like the hardest choices the optimizer has to make. After the game is done, there is some fix-ups and plan refinement where we fix all the details, and this is, in the end, we get the query plan. So in the trace, this looks like this: join optimization, select ID, then there's a steps, which is an array of objects, and there are different objects denoting different things. As you see, there is always an unnamed objects because objects can't have names. Then there is a name and either object or array. So the important ones are ref optimizer key uses. This is generating ref access. Rows estimation, then again, this is also an array, and for each table there is, we collect table information by estimating number of matching rows. The main game, the join optimizer choices in considered execution plans. And as a result, you get this best join order. And then there are some other fix-ups or plan refinement steps, depending on what is in your query. So let's look at these elements. Start with ref optimizer key uses. Ref optimizer, let's try a query. select star from T1, T2, where T1 key column equals T2 key column. This will give us an explain. It has put T2 table first, then there is table T1, and it uses index lookup, it uses key column, and it uses ref access. So a question one can ask, could this use the other join order instead from T1 to T2? Here, T1.key column is an integer, and T2.key column is a varchar of 100 with UTF-8 general CI. If you look at the optimizer trace, we will see ref optimizer key uses. It is an array that has only one element, T1 key call, and the value for it is T2 call. And note that there is no other vice versa. So we can make lookups one way. Interesting, let's compare that with the other way. What if both columns were varchars? Let's, instead of table T1, use T3 and write the same query. And here we see that lookup is possible in two directions. There are two entries. Here there was, well, if you know the optimizer well enough, you can guess that if in integer is compared to string, then they are compared as double values, and comparison of integers, which is this index is using, is compatible with that, while comparison of doubles is not compatible, because basically 0, 0, 1 is the same as 1 when you compare them as integers, but if you compare them as strings, these strings of 1 and 0, 0, 1 can be very far apart in different parts of the index. Well, but with the trace, you don't need to remember all of these details. You can just see that, okay, here there is a way to look up in table T1 from T2, but not other way around. This again can be looks basic and kind of obvious for these simple cases, but can get much less obvious for much more complex cases where there are complex where clauses and the optimizer makes certain inferences of them. And believe me, even for the query optimizer developers, it's not always apparent whether the optimizer was able to infer some equality or not. The second interesting part is range optimizer. Range optimizer is a part of the optimizer which looks at the where clause and infers which ranges we may scan to find matching rows. And this inference can get quite complex. The first source of complexity is multi-component keys. Then there are also inference using equalities. If call1 equals T2 and there is call1 less than 10, the optimizer will infer that call2 less than 10, well, in most cases. And the problem for all of that, explain format JSON will just show used key parts, how many key parts are used. So let's take an example. Here there is a table sum events with start date and end date, and there is an index defined on start date and end date. And then there is a query, okay, I'm looking for events with start date greater than June 24 and the end date less than June 28. Like I want to catch an event sometime. And the explain will show you that two key parts are used, but you might be surprised at a very kind of slowish performance, or the range access is not used at all. And if you look into the trace, you will see that surprisingly the second key part is only using null. Now the discussion of that is sort of outside the scope of this talk, but basically to be short is that the optimizer is actually not aware that the end date must be greater than the start date. And if you let him know that by adding these conditions, then you will see that the range being scanned is much more narrower, and there are a lot fewer rows in it. Another example with multiple ranges. Now let's write a query where start date is one of these 3 days, and there is just one end date. We will see that actually it generated 3 ranges, each of them using 2 key parts. Well, so far it's okay, but for longer or bigger in statements, there are this cross product of taking all ranges for key part 1 and producing cross product with key part 2 can cause some undesired effect against. So sometimes it is useful to know how the optimizer was able to handle it, because it employs some aggressive techniques to reduce the number of ranges it is producing. Closely related to range optimizer is so-called loose index scan optimization. Loose index scan optimization is optimization used for group by queries. It can be quite useful. Loose index scan can be quite faster than other grouping strategies. The choice whether to use loose scan is cost-based, so it depends on the data statistics and also on the data from analyzed table. It also has quite complex applicability criteria. So let's take an example. Let's create a table T and create a key of 3 components, KP1, KP2, KP3, and let's set 2 very similar queries. We do group by of KP1 in both cases. Then we want to find the minimum of KP2, that is for each group. And then there is a where condition, in this case on just KP2, and here it's on KP2 and KP3 also. And explain will show that this query is using loose scan while this one is not. And it's not at all clear why would that be so, until you look at the optimizer trace. And here you see that the loose index scan is used, and here it is not, and it's usable false, cause key part after infix in the query. So now we see that the problem is not data statistics, the problem is not analyzed, the problem is that in loose index scan is not usable here. Good, so let's get to the next part of it, join optimizer. Join optimizer is the biggest, most important part of the query optimization probably. And it produces 2 objects. One of them is considered execution path, and the second one is the best join order. Let's take a look at the example. Let's get a join. This is tables from DBT3 benchmark. There are parts which are produced by manufacturer. There are suppliers. And in the warehouse you have parts that are available in the warehouse. And so we write a join with these join conditions connecting part to part soup and part soup to supplier. And then there are also where conditions on manufacturer, on part manufacturer, on supplier's account balance. So we are looking at, we want to find parts from this manufacturer provided by the supplier from with negative balance, which we actually have in stock. And this is the explain. It shows the join order. Well, best join order will show us the join order as well. And considered execution plans object will contain a log of how the join optimizer has arrived at this query plan. Now it has a lot of content, so it's too much for the slides, or too much. It would be too much for the screen, so we would need to use grep. Join order is constructed in a top-down, that is first to last way, and there are 2 important member variables here. Plan prefix shows what is already constructed, and the table shows what we are trying to add. And the table always follows plan prefix, so if you just grep, if you just save the trace to the temporary file, and then we just grep for plan prefix and also ask it to print 1 row after the match. So this way we find that, okay, we started with empty plan prefix and edit table supplier, then we edit table parto, then we edit table part soup. And this was, then we got back to the prefix of just table supplier, and edit part soup, and edit part after that. And this is, by the way, the join order that the optimizer eventually decided the best. But it didn't stop here, it also considered 2 other prefixes. It didn't notice that here it didn't consider 3 table prefixes or full join orders. This is because the join optimizer aggressively prunes away. It tries to not to explore join orders, join prefixes which are not promising. And here we can actually already see which join orders, which prefixes were explored and which weren't. Let's look then at how join optimization proceeded for the join order here. So first, plan prefix is empty and the table supplier is first. If we search in the trace, we will find this one. Best access path is a function in MariaDB or MySQL source code which adds a table to the prefix. What it basically does, it considers various access types and it computes how many rows it will need to enumerate, what would be the cost, and then shows whether it's chosen or not. So here it chooses range access, which would produce this many rows. Yes, and it has chosen it. This is a rows for the number of output rows for the plan so far and the cost of it. Okay, so after the supplier, we get to part sup, prefix supplier, table part sup. That shows there are 2 ways actually to access it, ref access and full table scan. It picked ref access. And then there is a third one. Prefix is supplier part sup, and then we are adding table part. Again, there are 2 ways to read the table. We pick the ref access. And well, this is a good query plan without an issue, so we don't see any issues here. But in case you are wondering, is the optimizer considering to use certain index for this join order? Is it what estimates it's using? Here for the primary key, it's kind of obvious that there will be one match. For non-unique indexes, which have some conditions are constant and some conditions are not constant, the estimate here is computed with quite complicated computations, so it's interesting to see. If there is a where condition attached, the optimizer will try to estimate its selectivity and print it here, which this success rate of this, like say, varies a lot for not just for MariaDB. For this is a hard query optimization problem, so here this is something the optimizer can get wrong. This is how it rates. Okay, so this is the third table part. So we know that how many rows the optimizer expected to see, what would be the cost, join output cardinality. Let's look at why didn't it pick the other way? We saw that it went from supplier to part sup to part. How about part to part sup to supplier? We start with table part. It would use this table scan. This is how many rows it will produce. This is the cost of it. Then let's see, table part sup is added. Then there are 3 ways to read it. It picks the best of them is ref access on table. The best of them is ref access. But it shows that it has been pruned by cost. Yeah, so this is how you can view the details. So join optimizer takeaway. Consider the execution path traces the join order choice. It can get very large, so you have to use grep for plan prefix. Best join order will show the final prefix. By the way, hardcore JSON path users might want to, instead of grep, use searches like JSON extract and then use a filter. Unfortunately, one can't do this because MariaDB's JSON path implementation doesn't support filter. Neither does MySQL, by the way. So you'll have to use grep and get a good text editor to navigate this very large document. So things we've covered so far, we've covered ref access, rows, part of rows estimation, join optimizer. Well, there is a lot more in the optimizer trace. There are rewrites, various rewrites and transformations like view, CT merging, into exist subquery rewrites, min-max transformation. Then at collect table statistics, there is it reads data from histograms and tries to estimate selectivity. It searches for constant tables. Some tables are marked as constant. It shows the trace shows that. Table elimination optimization eliminates some tables, and it shows that. Then there is a conditioned filtering optimization, which we will see what filters are applicable for which tables. Unfortunately, this is all outside of the scope of this talk, but I hope you're getting the general idea about what kind of content is one can find in the trace and how to make use of it. Now let's look at the optimizer trace in MySQL. Now I don't want to have some kind of a match about which one is better, but I'm a big believer that we should, if there is something related or something that we could draw ideas from, we should look at it and discuss which of the implementations is better and how we could benefit. So, optimizer trace in MySQL is similar to MariaDB in both user interface and the trace structure and the elements you find in the trace. There are, of course, differences. First is that the optimizers are fairly different, so there are different things printed. Also, there are a slightly different set of things being traced. So, while the traces will resemble each other, I don't think just running diff might be hard. And then the tracing module in MySQL has extra features. So let's review them and see if there is anything we could learn from MySQL's implementation. So the extras in MySQL, the first one is that it can capture multiple traces for nested statements. If a statement invokes another statement, which can be done with a stored procedure when statement uses MariaDB will only save the trace for the top level statement, while in MySQL it will actually save the traces for substatements as well. This is controlled with optimizer trace of set and limit, so you can set it to save first or last end traces produced inside the statement. But the issue here is that basically there is no other support for troubleshooting nested statement. For example, you can't get explain output for this substatement. You can't get the statement time, how much time the statement has executed. Well, in some cases, you can infer the statement time and even number of rows examined from performance schema tables, but this only works if your stored procedure is very simple and doesn't have any complex logic. Because if it does, it doesn't show you the statement text, so it will be really hard to figure out which statement it has in mind. So my takeaway is that I don't think this is useful in this current shape. If you have an optimizer problem inside stored procedure, the practical way would be to take away that statement out of stored procedure and troubleshoot it separately. The second extra feature in MySQL, one can omit parts of the trace. They have optimizer trace features variable, which is a set of flags: greedy search on off, range optimizer on off. These you probably recognize. Dynamic range on off, repeated subselect. So you can switch these off and then the trace will not be saved for those. Well, my answer to that why would you want to turn them? It's not an issue. The issue is not with the trace sizes as such. The issue that we want to look at only particular parts of the trace, and typical workflow would be to use JSON extract to get the part of you need, rather than using flags to chop off the parts that you don't need. I agree that the flags would be useful for some global settings, like let's print cost values or don't print cost values if you don't care about cost values, which apply to all elements in the trace everywhere. In other words, I don't consider this. This is something we could add, but I don't think it's very important or very needed. Yet another extra is in MySQL, one can control the way JSON output is formatted. The first thing that you can set one line flag to on in the optimizer trace variable itself, and in that case you will get trace in one line, which will probably make it take less space, but again, I personally never saw any need for it. The other one is that you can set, there's a variable called young markers in JSON. If you set it to true or on, you will have these young markers, so steps. When the array ends, you will have this comment indicating that this is steps ended, and so forth. Well, this improves readability somewhat, so somebody might find this useful. My issue with this is that JSON actually doesn't allow comments. So if you set this on, the output is not a valid JSON anymore. You can't pass it to JSON extract, for example. And maybe this should not belong to some global variable which suddenly makes JSON something non-JSON, but rather a function which prints it. It would also add something to make it more readable. Yet another extra is that tracing in MySQL covers some parts of the query execution. Most notable users file sort. For example, if you want to know whether file sort is using priority queue optimization, this is not shown in explain. You can only get it into if you enable the trace and run the select, not explain, but select itself. This also shows like a C memory available and other details. And well, my guess is that MySQL had to put it somewhere. They couldn't put it in explain for technical reasons, and they didn't have explain analyze back then, so they had it save it in the trace. This is actually not a very good idea, because if the file sort is done in subquery, this will produce loads of repetitive JSON, and that's why they needed to disable it here in repeated subselect to avoid producing really large JSON documents. Well, in MariaDB, this kind of information is shown in analyzed format JSON output, which is the command specifically targeted at collecting runtime statistics. So we don't have and don't think we should have this in the optimizer trace. Analyzed format JSON shows roughly the same information. Okay, so that's for extras in MySQL. What's extra in MariaDB? In MySQL, in one word, just like I would say, more polish. We were trying hard to eat our own dog food and use trace for performance troubleshooting we do. So things that we did, we made printout of conditions more readable. Here's how condition looks at MySQL, and here's how it looks. The same condition looks in MariaDB. This may not look like a big thing, but this amount of ridiculous overquoting makes conditions really hard to read, especially when the query is large and conditions are long. Well, we saw that data constants are printed as hex, not dates. We fixed that. The important thing did other similar smaller fixes. The important thing is that MySQL actually prints incorrect for range analysis for multiple key parts. We had a similar problem. We made the similar mistake in MariaDB, but we had caught it and fixed it before we released. Here is a bug in MySQL which shows that when I reported it to them, they didn't seem to care. So conclusions. Optimizer trace is available in MariaDB. It shows details about query optimization. You can analyze it yourself, or you can save it and submit traces when discussing or reporting the optimizer issues you encountered. MySQL has a similar feature that has some extras compared to MariaDB, but they don't seem to be important. Our future plans mostly is about printing more useful information in the trace. We don't want to print everything there to flood it with content. It's already quite large, but we want to use our experience to find what would be useful and add printouts for that. So submit us, if you encounter optimizer issues, submit us them to us together with traces, please. So that's it. Thanks for your attention.
Thank you, Sergei Petrunya, St. Petersburg, Russia. Did you explain the trace or trace the explain? Which one was it?
It was explaining the trace.
So can you explain to me as well whether the trace could always be enabled, and then you would save just the trace is so poorly performing queries, and we would get to see the bad situations only?
Well, this is what in ideal world we would like to have, but there is a problem with that producing the trace has some noticeable overhead. Especially for smaller queries which execute fast, producing the trace has like in tens of percent overhead adds this overhead to optimization. So that's why it's not a good
overhead. I can get why that is not always turned on then. Well, yeah. Then another question, is it sufficient to run the explain just the explain with tracing, so the tracing the explain, as you said, or are there cases where I should run the entire select, not just the explain?
Well, the slides show that in MySQL sometimes you have to run the select because they print some information on runtime. For MariaDB, in like 99% of the cases, running explain would be sufficient. There are some leftover or special cases differences when between the way select is executed or explain is executed, especially with prepared statements. So in those edge cases, there may be a need to run the actual select, but I expect this to be exceedingly rare.
So in theory, yes, but in practice, seldom. Yeah. So then we use optimizer switches to try to persuade the optimizer to use to follow our will. What's the relationship with this trace facility? Can I then see whether I succeeded in persuading the optimizer to follow by my wishes and advice according to these switch flags?
Yeah, I was actually asked a similar question on different occasions, like how do I know for this certain query which flags affected the way it was optimized? If you have a very good knowledge of the optimizer, you can see that, but unfortunately it's not directly. We don't have it printed in the trace like, okay, at this point we check the value of this flag and this optimization is on, and that's why, because here you get the next object in the trace describing how we attempted to apply it. Or it was off and we didn't consider it. So at the moment, the knowledge is there, but it's not direct. The value, if you're looking for the value of or names of flags printed into the trace, it's not there. And it would serve some educational purpose, but I'm a little bit wary of adding too much content to the trace because it's already very voluminous.
Already big. Yes, so speaking of the content of it, JSON is one format, but hey, there are people out there that I talk to that say YAML for the win. I want YAML. So could we do YAML instead or on top of it?
I agree that YAML would looks better than JSON. I assume it's possible to come up with a mapping between YAML and JSON, a function which would take YAML and get JSON. There is an advantage in JSON that we can have JSON processing functions. We don't have YAML processing functions in the server. But so one could get first JSON, then process JSON as needed, and then call the function which converts to YAML. By the way, having this, we don't have such functions, so it would be a good idea to a good contribution. It's not tied to the rest of the server code, so if somebody is having an itch to scratch, they could contribute this function, which would be then usable.
So you pick JSON because there's already functionality inside MariaDB Server that gives you for free that functionality, and there isn't for YAML. But you would, if somebody contributed this, like a conversion from JSON to YAML, would you then look at that pull request and look at it favorably and perhaps have it merged?
Yes, sure. Well, pull request, there is a list of things that pull requests must conform to, but this is a function. Well, one of the problems that MariaDB is in many packages. So we would have if there is a library, there is a dependency on some library, that could be a difficulty there. But if there aren't any, we are open. I think we should be open to accepting this useful function, which doesn't have any overlaps with the rest of the code, so it should be fairly technically easy to accept.
So hey, that was a great piece of advice for those in the audience who are interested in contributing to the MariaDB server. Yes, we are mostly talking to DBAs and developers of software using MariaDB, but this seems to be a low-hanging fruit for contributing code. If we follow your advice of not entering dependencies on some individual platforms, this seems to be a place to do a great first contribution. Is that correct?
Yes. Yes.
Good. Well, I think that's also as much time as we have. So thank you very much for explaining the trace and tracing the explained Sergei Petrunia.
Thank you too. Enjoy the rest of the conference.
Our next presenter comes from Codership Galera. It is Seppo Jaakola, who will be talking about MariaDB Galera cluster.
Welcome to MariaDB Server Fest 2020 and a presentation about MariaDB Galera cluster. My name is Seppo Jaakola. I'm a CEO and developer of MariaDB in Codership. I have a quite long track record of clustering solutions, already 15 years and over. Codership itself is a small technology company focusing in research and development, mostly around replication solutions for open source databases. Galera cluster is our product. We have started to work on that in 2008. We do business through support and consulting, and we are partner of MariaDB, and we are member of MariaDB support team for Galera related topics. Agenda of this presentation is just a very general overview of Galera replication, Galera clustering in MariaDB. There will be another presentation about Galera new features you can find in Maria 10.5 and 10.6. That presentation is also in a MariaDB Server Fest happening later on. But this is quite a general overview, just basic concepts of Galera clustering. I'm looking at the configuration of Galera cluster, how you can turn your MariaDB server to work as a Galera cluster, synchronous multi-master cluster for MariaDB. An overview of the features of what you can gain with such cluster solution, and then a few words about releases and release cycles of the Galera releases. So let's go ahead. This is a standalone MariaDB server you can get from the MariaDB distributions. So you have a clients connecting to just one MariaDB server. If this is a MariaDB 10.1 or later, you already have all the Galera software installed in your installation, so you can just by configuration turn it to operate as a node in a Galera cluster. Galera is a plugin, replication plugin, and in a configuration you need to tell that where the plugin resides. You have it in your installation somewhere on your disk. Documentation should tell where it resides. And in a configuration variable VSREP provider, you give address to this plugin library implementation. And with that, when you start your server with such a configuration, you have a single node MariaDB Galera cluster, just one node in a cluster. That's not yet a very functional cluster, so you need more members. You should start a secondary node telling it to use a Galera plugin, and also you must tell that the address of the other node in a cluster. The address is given with a configuration variable VSREP cluster address, and it's practically just the IP address of the other member in a cluster. In principle, all nodes that you configure for your cluster should have the VSREP cluster address specified, and it's a good idea to give them the full list of all potential members that your node might want to join to form up a cluster. So if you have 3 nodes, you should in your VSREP cluster address list all these 3 IP addresses. This VSREP cluster address variable is used only for the handshaking of the part of the protocol when the nodes join to the cluster. After that, the VSREP cluster address variable is not used at all. The third configuration variable here is VSREP SST method. It tells the method how a new node joining to the cluster can get the copy of the database, so that it would have the same data content as the rest of the cluster has. Here in this example the method is rsync, so the joining node will just get an rsynced copy of the data directory. So all the files that are present in the first node will be just copied over the internet to the joining node. And with this configuration, the cluster will handshake with the joining node and then send the fresh copy of the database through rsyncing to the joining node. And when this copying is complete, the node will be an active member in a cluster. All transactions happening in both of these nodes, actually, they will be synchronously replicated between each other. However, 2 nodes is not yet a very functional cluster. You should have 3 or more. So you just need to make another installation of the same MariaDB server, configure the plugin and the cluster addresses correctly, and then join the node. And then you have a functional 3-node cluster. This is the minimum recommended size for the cluster, just for the sake of these nodes or the cluster to decide that if there are communication problems between the nodes, then the cluster must find out if there are 2 nodes who can communicate with each other, then that part of the node will be the majority, and the third node will be kicked out for a while until he gets a better connectivity with the rest of the team. 3 nodes is the minimum number to make a meaningful voting in error situations. Usually the clusters that are deployed, they are 3, 4, 5. These are maybe the most used cluster sizes. People are usually using Galera cluster for data safety reasons. The more nodes you have in a cluster, the more copies or backups of your data you have actually in place. Every node in a cluster is a full backup of each other because of the synchronous replication that the cluster is carrying out. all writes in the cluster, they will be replicated immediately to the cluster. If you write to the middle node, the transaction will be replicated. And the transaction will be committed only in the middle node in this example. It will be replicated to the two other nodes, but not necessarily committed yet before the client gets the OK status back from his commit. So we know that the commit is really complete in one node, and it may or may not be complete in other nodes, but every node has the transaction, has received and acknowledged the transaction. And also these nodes, they will, when later on, commit the same transaction. That much guarantee for synchronicity Galera cluster provides. All nodes can be used for reading, so you can safely read from any of these nodes. There are nothing preventing that, of course. And the reads are very, very close to each other, so the cluster progress is very even. It doesn't really matter where you are reading from. You will get the same results in practice. In a nutshell, Galera replication is a generic plugin for any database server. When we started to implement the Galera clustering, we first defined definition of API between any database server and a replication plugin. And this project there's a separate project for this. We call it Write Set Replication API project, or VSREP for short. These clusters that I implemented with Galera, they replicate write sets, which is practically the change set of happening in a transaction, and this change set is then replicated over the replication layer and then applied and made persistent in every other node in the cluster. When a database server provides this API, then it can load Galera plugin, and with that there is one node of a cluster, and having more of these nodes will build up a database cluster. With MariaDB having a MariaDB 10.1 or later installation, you just make a configuration through VSREP_variables, and then you can start playing with the cluster itself. Here is the full list of configuration variables available for Galera clustering. This is listing from MariaDB 10.4, a big number, very small text, but let's not go through this list in more detail. In practice you only need just a handful of variables for tuning. Usually it's about telling the provider and the cluster address and the SSD method. That usually is enough for a configuration. There are also status variables just to see that how the cluster is doing, and monitoring tools use these status variables. In Maria 10.4 the number of status variables for VSREP is 66. Three most used ones are VSREP ready for the cluster readiness of accepting transactions, cluster status, and cluster size. Usually monitoring solutions pull these variables to see that the overall status of the cluster. Then there are a big number of other status variables to see that how transactions are doing in a cluster, or all other aspects of the cluster healthiness. Besides of these variables, configuration variables and status variables, there are also free tables for cluster information. You can find these in a MySQL schema, VSREP cluster, VSREP cluster members, and VSREP streaming log table. The cluster table is just the definition of the cluster, the name of the cluster. VSREP cluster members. It has more information. It lists all the active nodes or members of this cluster, their names, addresses, IP addresses, and UUIDs for these nodes. So if the cluster size is 3 nodes, you should see 3 lines in this cluster members table as well. And finally, streaming log table. It's about a new feature that we added in Galera 4, which incarnated in MariaDB 10.4 release for the first time. Streaming replication is a method for replicating very big transactions or very long-term transactions as well. Galera 3 and earlier installations had a problem that if the transaction size grow over a certain limit, it could cause problems or big delays for the cluster, just because of the size of the transaction was too much for the replication system to handle. With streaming replication that we implemented for Galera 4 installations, we are splitting the big transaction to small parts, which we execute in every node at the same time in the cluster. So the transaction is kind of processing in small pieces in every node in the cluster. And the status of and state of this transaction execution is stored and maintained in this VSREP streaming log table. It can be, we use it, we as a Galera developer, we use it for guaranteeing recovery for such long-term transactions in case of any cluster problems, node hangs or node crashes or reboots. We can always take back the long-term transaction. But it can also be used for monitoring and just picking that what kind of long transactions you have in your system, how long they have been processing, and it could also be one method for troubleshooting if there is a ill-behaving long transaction going on in the system. The features that Galera cluster brings is first and foremost is synchronous replication. As I said, it's not fully synchronous, it's close to fully synchronous, but the commit is guaranteed only in one of the nodes in a cluster. But you can see or make your session to have we can call it a look and feel of a synchronous replication. There is a session variable VSREP sync wait, which you can specify so that for example, your reads, when you read something from a node, it would wait until the slave replication queue is fully committed, so that guarantees that you will see all the earlier writes. You won't start processing your reads before all incoming writes have already committed. With that makes reads somewhat slower because you have to wait until replication queue is committed. The good news here is that the replication queue is usually very short, and that's because Galera cluster implements flow control, so that if there are pending transactions goes over a certain limit, by default it's only 16 transactions. So the queue you can queue up 16 transactions, and after that the cluster starts sending flow control stop signals so that every node will wait for the slowest member, and keeping the pace of execution in the cluster even for all of the nodes. Therefore, having the VSREP sync wait configured usually doesn't cause too much delay for reads as well. The installation for Galera cluster nodes makes those nodes to be equal in terms of reading and writing. You can always read from any of these nodes. You can write to any of these nodes. Galera cluster does not give you any does not stop you doing that, but if you want to use Galera cluster as a master-slave topology, you should have a read-write splitting happening in upper level in load balancer or proxy, or sometimes some applications are clever enough to figure out that where to write to and where to read from. But for Galera cluster, there is no restriction. You can always write to any of these nodes. Most installations are working in a master-slave model, so that the application or the load balancing layer will provide this read-write splitting and managing it. It's for simplicity reasons mostly. Also, Galera cluster can sort out conflicts, so you can write to any of these nodes, any table, any row. There can be row level conflicts, but Galera cluster will pick a winner and loser for any conflict, and the loser will just roll back the transaction and get a deadlock error as well. Galera cluster can retry a failed transaction because of such conflicts, so that the client doesn't even get the deadlock error. Cluster retries it, and if it's successful, the client will see that my transaction execution took 2 times longer than usually, but it was successful. So this kind of automation is also possible to have there for multi-master use cases. And finally, we have added quite a lot of automation for Galera clustering. So in principle, you only need to make the configuration correct for all the nodes. You specify the cluster addresses correctly, and after that, if you start a node, it will automatically join. Eventually, if the database size is big, if it's terabyte, it can take hours, but eventually it will be a member in a cluster, have a copy of the database, and then will be a member in a cluster. If a node drops out from the cluster for any reason, it will usually retry to join, and it might be that the administration doesn't even know or see the effect that node went out before it has already automatically joined back to the cluster. That could also happen. How much different this is then with respect to asynchronous replication? Practically all what was listed in the previous slide are actually the differences between Galera replication and asynchronous replication. In asynchronous replication, you can only write to master server, and then all the slave servers they are used for read-only purposes. Slave nodes, they may fall behind, so there can be slave lag, and that's because there is no flow control in asynchronous replication topologies. Master is as fast as possible. They allow us any transactions to come in, and if the slave servers cannot keep up with the pace, then they will just fall behind. If a master server needs to be replaced for some reason, then the whole topology must be reconfigured so that there is a new master. New master must be picked up, and every server must be configured to know that where the new master resides. So that's a management burden to have all that organized. If you are using Galera cluster for master server topology, you just write to some other server node in a Galera cluster, and that's it. So no failover needs because of Galera in such scenarios. How about the versions then? So we started the Galera development in 2008, quite long stretch already, like 12 years of Galera development. First versions for MariaDB came, if I remember correctly, for 5.5 and then also 10.0. But starting up to that point, there were there were additional Galera clustering implementations that were not part of the MariaDB software stack itself. But starting from 10.1, Galera clustering is accepted as in MariaDB mainline. So with later MariaDB releases, you get a Galera cluster, Galera replication included, and it's up to you to make the configuration to start using Galera cluster. Turn your MariaDB server to a cluster working with Galera replication. We have given Galera major version numbers starting from 1, and the most recent one is now 4. These are versions that make a big impact for the overall behavior of the cluster. They also contain a jump in the VSREP API, so the replication API has changed, and the way that the Galera plugin and database server communicate has been changed. And because of this changes in this API level, then whenever there is a major Galera major version upgrade, it means that we also need to prepare a rolling upgrade path for the solution. For database users, it means that when you step, for example, the last big change was between Maria 10.3 and 10.4, and upgrading from 10.3 to 10.4 needed to happen in a certain way to make it safe. You need to have your first all your nodes in a cluster to be upgraded to the latest 10.3 version, and then node by node, just upgrading one node in a cluster to operate as a 10.4, and then the second node, and when the last node of the cluster has been upgraded, then the cluster is in the level of 10.4, and after that the internal replication in cluster starts to use the Galera 4 replication methods. You cannot downgrade after that, so your cluster is then in a Galera 4 level, and your upgrade is complete. This rolling upgrade is usually quite tedious job to do, so testing wise we have to do it, reserve quite a lot of time to do that carefully and make sure that all live systems can be safely upgraded to the new version. Because of this, we want to pack all changes for the replication API to happen not so often. So the Galera replication 4 came with Maria 10.4. Now we have a 10.5 which is using the same VSREP API level, and for Maria 10.6 we have not yet decided that what kind of features will go in there, but it may be that there's a major change in a Galera or not, but this is something to be decided actually quite soon, in a matter of 1 or 2 months. Alright, last slide here, summary of this presentation. Galera clustering itself, it's present in MariaDB releases for a very long time. Starting 10.1, it's already in every Galera MariaDB release. Reason to use it, what people are saying is that synchronous replication first and foremost, quite most often looked reason. Then the data safety, because of the fact that every node is a full backup of each other. That's also seemed quite important feature. And multi-master needs sometimes not so much that we were anticipating when we started to use the develop a Galera cluster. We were hoping to see the performance impact of writing to several nodes, but that's not something that that the applications need so much. But its multi-master use case is good for generality, so that you could treat your cluster equally. It doesn't matter. You don't need to care where you write to. And if your application is not sensitive to conflicts, write-write conflicts and seeing deadlock errors, then this might be a good solution for such application as well. Galera works well in wide area network and cloud installations. No problems there. It's mostly because the replication itself it's not sensitive to latencies in the network connections. Galera 4 came with MariaDB 10.4, and it has 10.4 overall has significant new Galera 4 features and other MariaDB features as well. So if you want to start evaluating and experimenting with Galera, I suggest you begin with 10.4 or later, just to avoid the rolling upgrade that you would need to do if you are in 10.3 or earlier. You have a one sure rolling upgrade experience coming up quite soon. This rolling upgrade, as I said, it's supported so far for all versions, and that's our policy that our users they are usually running clusters which need to stay up 24/7. There is usually not much accepted downtime for the cluster, and because of that we need to make sure that whatever we release it's possible to upgrade online in a hot system. That's all from my part, and I guess questions are coming in a separate session after this airing, and don't forget the next presentation. It's also coming from Galera cluster about 10.5 and 10.6 new features coming later. Thank you and bye bye.
Thank you, Seppo Jaakola, for a great presentation. And thank you for joining on behalf of Codership Galera from joining the MariaDB Server Fest in New York from Helsinki, Finland.
Thank you. It's nice to be here.
Good to have you here. So I'll start with an easy question for you, a really basic one. What's the basic use case scenario for Galera cluster?
Well, when we started the development of Galera cluster back 12 years ago, then our primary goal was to get a good write performance, and that's what people want. But quite soon we got to realize that the most of the users that are using and deploying Galera clusters, they are actually looking for the synchronous replication behavior of Galera cluster. There are certain applications which have a strict requirement that they cannot lose a transaction, and for that you can only guarantee by synchronous replication. Application feeds like financing and gaming, they usually have these requirements, and quite often it's with asynchronous replication you can get a really good guarantees, but it's not foolproof, so you cannot claim that you couldn't ever lose a transaction. And that, I think, is the first and foremost reason to start using Galera cluster.
And I suppose that's also the answer to my follow-up question, which is you're talking about 3 nodes or more. If I just use 2 nodes, there's more risk of losing transactions, is there?
There is some risk, but it's not actually the same as with synchronous replication, because with synchronous replication we can guarantee that if a client issues a transaction and commits, and if it gets OK status from the commit, he knows that his transaction is saved in the clusters. If he loses nodes, then some nodes are up. But this requirement for 2 or more nodes is more for data safety, so that the more copies you have, the more nodes you can eventually lose. And it's free actually is also the smallest number of voters you need to have a democratic vote. So if you have a 2, then they can vote against each other, and you cannot make a cluster who could decide that who's up and who's not.
Makes sense. So what about the software around Galera cluster? Like, how do you recommend that one should connect the client to the cluster? Do you have a recommendation for a good load balancer, a good proxy, or something like that?
That's not so much our concern. So we are working in a replication layer, and the load balancing is much higher in the stack. We rarely get to see on that level. So, but just for the simplicity for the application use, proxies are much better. Like MaxScale, you can configure your cluster and your whole software stack so that the application doesn't need to know that where the master node resides, and MaxScale can take care of that part.
Mm-hmm. So then there's a statement where you say that the cluster resolves multi-master conflicts. That sounds great, but how does it happen?
There is academic research for that, and that's actually the this dissertation paper that we first read about explained this fully. But just to put it in a nutshell, we collect from every transaction in a cluster certain metadata which describes that what tables and rows have been modified in this transaction. And all these transactions, when they come to replication layer, we can see from each transaction up front that what modifications are made, and if there are conflicts between 2 transactions in the replication system will choose the first come will be first served and get to commit, and the later coming will lose the battle and he needs to roll back. For the application, it shows up like a deadlock error, so it's not a bad thing, but he just needs to retry.
Okay. Well, I'm looking forward to hearing more like about the latest developments. So you're up next again with a new presentation on the newest features. So thank you for the introduction, Seppo Jaakola.
Thanks.
Now for a look forward, the Galera clustering in MariaDB 10.5 and beyond by Seppo Jaakola.
Welcome to MariaDB Server Fest 2020 and a Galera cluster for MariaDB presentation. My name is Seppo Jaakola. I'm a CEO of Codership and a MariaDB developer. Codership is the smallest technology company focusing in research and development for open source replication solutions. Galera cluster is our main product. We have been working with that since 2008. We do business through MySQL and MariaDB consulting and support, mostly with MariaDB Corporation. Since 2007 we have been doing continuous growth, and our team is growing constantly. Here is the agenda for this presentation. This is about Galera cluster in MariaDB, the newest, latest features of that, so it's more technical. There is another presentation in MariaDB Server Fest, which operates more like an overview on an introduction to Galera clustering. In this presentation, I first talk about Galera releases, how Galera came to be in MariaDB. Then the newest major features, practically Galera 4 in Maria 10.4, and new features we have been adding in MariaDB 10.5, and also some features that we plan to put in 10.6. The development for 10.6 has already started with our team. Galera cluster development, it started in 2008. It was first only for MySQL, but quite soon we all started to develop also versions for MariaDB. Up to 10.0 release, the Galera clustering in MariaDB was an add-on product, so you had to have a separate installation for MariaDB Galera cluster. But then since 10.1, Galera has been integrated in MariaDB mainline. So if you have a MariaDB 10.1 or later, then you also have a Galera product included. It's only a matter of configuring your MariaDB server to work as a Galera cluster. 10.2, 10.3 were just minor releases from Galera perspective. There were many major versions, of course, for MariaDB, but for Galera clustering, not that big improvements. But in 10.4 we had a Galera major upgrade. We started to use the latest Galera 4 replication there. It included also the replication API change, so the integration or migration from 10.3 to 10.4 requires more attention because of this. And 10.5 came out this summer. It's the latest from our side, and in this presentation I look mostly on the features that came in 10.4 and 10.5 and also the new features planned for 10.6. When we talk about Galera releases, we have divided major releases with just a small integer number. We started with 1, 2, 3. Now the latest one was called Galera 4, and that's present in MariaDB 10.4 version. The replication API that we call VSREP API, it has also integer number, but it goes from 1 to 26, so there has been much more API changes than the major Galera version changes. But what matters for the end user is that whenever the replication API is changed, then the upgrade can be more challenging. It requires a rolling upgrade path, and that's what actually we had to do in our development, so that we test that carefully and provide a way to have make it possible to upgrade a full operating cluster without any downtime to the new version of Galera replication. Galera 4 releases in 10.4. It included this API change, as I said. The latest VSREP API is number 26. The biggest feature that we brought in there is streaming replication. Streaming replication was originally implemented to support big transactions or long-lasting transactions as well. Here is an animation that how streaming replication can support a long-term and a big transaction. We have a client and a free node cluster. When the client starts a big transaction, it first launches in the first node, but as soon as we detect that the transaction has a big size, we replicate it to the cluster so that every node in the cluster will also launch a matching stream replication transaction. And when the transaction processes, it provides some result sets. All these results are then replicated, so the transaction is live in all of the nodes in a cluster. So in a sense, it's a distributed transaction processing system. And when the client finally commits, all these transactions will commit in the same time. It looks quite simple from surface, but developing this and making sure that it's always safe to use that, and it's also safe when there are changes in the cluster. Let's say that the node goes down or more nodes join to the cluster while there are ongoing streaming replication transactions. the cluster does not know that when the transaction eventually will commit, so there is no guarantees that upfront that we could decide that should we wait or not for certain operations. The cluster must be able to handle all possible situations. Because of this, and to make it safe, the development cycle for streaming replication alone was very long. It was like 3, even 4 years to take it from drawing table to the final release. We were suggesting streaming replication already for MariaDB 10.3, but it didn't catch that train. Then it was delayed, and finally in 10.4 we got the streaming replication in the MariaDB releases. GTID compatibility work started for 10.4 and is now present in 10.5 release. It's a work done by Mario Caruso. The underlying problem or the challenge of GTID support is that Galera has a GTID of its own. It has 2 elements, UUID and a sequence number of the transaction, whereas MariaDB has a 3-element GTID with domain ID, node ID, and a sequence number. The plan and design for GTID support now for Maria 10.5 is to make Galera cluster to also provide similar GTIDs in the format of MariaDB. For this reason, we use the same domain ID and node ID in every node in the cluster, so that the end user of MariaDB cluster would see the cluster as just one single MariaDB server with the same domain and node IDs. Galera cluster will now store and show for the end user only MariaDB format GTIDs. And Galera cluster can also operate as a slave for external MariaDB master server, and the GTID coming from the MariaDB master server is also preserved in a Galera cluster, so you can find the same transaction that was committed in the MariaDB master server. You can find the same GTID also in the binlog files of a MariaDB Galera cluster. Cluster error voting is also a feature that came with the 10.5. It's work by Alexei. The idea here is that there is a new protocol for cluster nodes to agree what to do when one or several nodes in the cluster have problem in applying of incoming transaction. The problem could be suspected inconsistency or some other reason for not being able to apply the transactions. Here is an animation how it goes. We have one client sending a transaction, maybe a problematic one, and a 5-node cluster. The client finally commits the transaction. As usual, the commit is replicated to the cluster. Cluster is happy with it, so the commit gets OK status packs. Client thinks that commit was successful. Well, it was, at least in the first node. But the applying of this incoming transaction, it can happen somewhat later. And in this case, 2 of the nodes have problems in applying the transaction. So they saw that this is not possible. And now the error voting protocol kicks in. The first node seeing the problem sends a message to the error voting protocol, and then every node in the cluster starts to vote, telling that what was my success with this incoming transaction. The healthy nodes say that okay, this I had no problems, but 2 of these nodes tell that I had a problem. And when every node sees the votes coming, then the nodes that see that they are in a minority, they will just shut down. And as the end result, we have only 3 nodes in a cluster. From the end user perspective, he issued a transaction. It was good. And also the cluster is good after that. But 2 nodes went down, so the DBA should step in and take another look at why these 2 nodes failed to apply the transaction, and then fix the problem if there is some, and then rejoin these nodes back to the cluster. XA transaction support work by Daniele and Leandro. What we mean with XA transaction support is that we want to make it possible for Galera cluster to operate as a resource manager in an XA infrastructure. So there's a transaction coordinator somewhere else who wants to operate with several resource managers, where a Galera cluster is just one of these resource managers. So Galera cluster should be able to prepare an XA transaction, and after prepare to either roll it back or commit. If it has prepared the transaction, it also must be able to commit if the transaction coordinator wants him to commit the transaction. This XA transaction support is possible after we implemented the streaming replication. We use the streaming replication as a foundation for running XA transactions. We had this work already ready for 10.4 release, but it was not accepted there, and we moved the target to 10.5, and we almost got it there. During last springtime it looked that okay, we have a Galera XA in 10.5, but what happened there behind the scenes is that 10.5 had also some other work related to XA transaction support in the MariaDB proper side, and that work conflicted with our work for Galera replication, and we had to wait to get the MariaDB XA implementation first in. And finally it came out that there was not enough time to get our work done and we'll test it. So we left in a situation where we had to just pull back the proposed Galera XA support for 10.5 and delayed it to be scheduled for 10.6. So it's a practically 1 year delay for getting XA support for Galera cluster in the MariaDB. I have 2 features, non-blocking DDL, to discuss also. It's quite long-term work that we did. My font is yellow here because this is not in MariaDB community server, it's only in MariaDB Enterprise Server Edition. For that reason I'm not in this presentation going through the details. I'm just telling you that this work has been done. It probably will be later in MariaDB Community Edition as well. This is work by Teemu, and the idea with the non-blocking DDL is to execute the DDL in 3 phases, where phase 1 and 3 are blocking ones, but they are very short. We do those phases just to agree on taking a metadata log for the later coming DDL operation. And the phase 2 is the long-lasting phase where the DDL is actually rolled into the system, but the cluster is not logging that phase. There is only the metadata log protection for that operation in place. For configuration, we have one new online schema upgrade method, NBO, that can be chosen. People usually use the total order isolation, but with the MariaDB Enterprise Server it's possible to use the blocking operation as well. Another one on MariaDB Enterprise only feature is black box, work done by Pekka. Black box, in a nutshell, it's a It's a debug message storage held in ring buffer in main buffer. So when the MariaDB server is operating, it stores all kinds of debug level information in a quite small area in a ring buffer. And if the server might crash brutally, we can always go back to the black box to take a look at what happens in the last seconds when the node was still running. It helps in troubleshooting a failed cluster, or we have found out also that it's very helpful in testing, cluster testing as well. And finally, the last slides of this presentation is about MariaDB 10.6 planning. We completed our 10.5 related work in early summertime. We have this XA transaction support that was practically ready for 10.5. We continue with the testing of that and also documenting it, so we should be very well prepared for 10.6 release to have the XA support finally in. But this implementation, one of the reasons to implement XA transaction was our interest to fundamentally to implement the sharding cluster based on Spider storage engine, and this work we can now do. The Spider cluster would operate like this. So we have the Spider cluster is the upper level cluster with 3 nodes using Spider storage engines, and then we have a cluster for each shard of the Spider engine. In this example, there is only one table, Spider, which is belongs to the Spider storage engine, and it has 2 fragments, A and B, and each of these fragments is then served in respective Galera cluster. On the left-hand side, shard cluster has 3 proper Galera nodes, and the purpose of this cluster is only to serve the incoming XA transactions related to changes for the fragment A of the Spider engine table. The right-hand side shard cluster has 2 proper nodes and an arbitrator, so that would be the minimal deployment type of a sharding cluster. 2 proper nodes for data safety, and then the arbitrator for all kinds of voting situation if the cluster has some kind of hiccups in the communication. In real life, you obviously will have a lot more fragments or shards in your table, and a big number of servers needed to run these kind of topologies. But this is interesting work, and mostly because it's the way to the final way to the write scalability. The performance and kind of the workload in each shard cluster is quite minimal. It's only each shard cluster needs to care only about the data that's one part of the big table. So the load per shard cluster is quite minimal. The only question is for the overall throughput of this system is that how big a bottleneck the Spider engine will be in the upper level Spider cluster. We have started some ongoing work for 10.6 as well, so the XA and Spider cluster testing will be of course part, but some other work that we do for 10.6. We started with the test system improvements. That doesn't show up for the end user so much, but for development it's very important part. We are extending the test coverage and improving the tests so that they would be deterministic and not so false positives so often. It will help in a development and avoiding regressions in the future releases. 2 new features are have been worked on. First one is dynamic SSL or TSL encryption. Earlier you had to either use SSL encrypted group communication or not. You needed to do that up front, but now you can dynamically switch on and off, and you can change, for example, your SSL implementation to have another implementation variant of the encryption used for the cluster. This work is code complete. It's in a testing phase at the moment. Another one is the optimization for streaming replication. The way that we implemented streaming replication for the first version was very conservative and safe, just to cover all the possible error scenarios when cluster has members dropping from the cluster and joining in, and we had to make sure that it's always possible to recover an ongoing streaming transaction. Because of this, we used quite a lot of extra resources, and that caused the actual long-term transaction to last a lot longer than it would in a for example, compared to a single node or a standalone MariaDB server operation. But with this optimization, we plan to make the transaction throughput of such large transactions much faster. This is in a research phase, and the implementation has just started based on the design that was done in a research phase. So these 3 tasks are ongoing. Then we have a list of feature requests that we have got during the 10.5 cycle, and what we are hearing from MariaDB Corporation as well. The list is quite long, like 20 to 30 new features. We cannot do all that for 10.6, but during the next 1 or 2 months we will pick up the winning features that we want to put in 10.6 for the next springtime. Yes, that's about all for Galera cluster 10.5, 10.6 for MariaDB. Thank you for listening, and have a nice MariaDB Server Fest 2020.
Now that's the Seppo Jaakola I know talking about the latest features of Galera. So thank you, Seppo, for staying up late. You're calling in from Helsinki, Finland, aren't you?
Yes, I am. It's good to be here.
Good. It's good to have you here. So streaming replication, that's something you speak about. How should I use it, and especially from a performance perspective, what does it mean?
I'm glad you asked. It's my favorite topic, this streaming replication work. We started it like maybe 4 years ago, and it was a really long stretch to get all the pieces together. The original reason for this, why we started to work on a streaming replication, was that we realized that how harmful such big transactions actually can be to the cluster. The biggest impact that I witnessed with a DBA online on a call, when he had one such big transaction, it caused a 27-minute cluster stall in total. And the reason why this happens is that in a synchronous replication in database clusters in general, you have to provide a strict commit order. So whatever order you have decided for the incoming transactions, every node must commit them in this strict order. There cannot be any changes in that. And the problem is that it may look quite nice when you look at the first node in a cluster where the connection goes to. You can have thousands of connections in parallel, and this node performs quite well. There can be one transaction that is long-term, it's just populating a lot of data, but it doesn't hurt any other transactions processing in this node. But when the big transaction commits and we compose the big write set to the cluster replication layer, and it goes to the cluster, every node must first apply this transaction and finally commit, and in this strict order. And when the order for this big transaction comes, there's a big queue of smaller transactions, but they just have to wait. It can be half an hour, so it's that was the reason. And your question was that when you should use it, and with this first implementation that we actually brought to the bigger audience with MariaDB 10.4, the implementation is just made to show that it's safe to use it in the first place, but the performance is not very good with that. You should use it to cut just those big harmful transactions and not configure your system to use streaming replication for all of your transactions. That's the intended use case for in Maria 10.4 and 10.5 as well.
Mm-hmm. So let's take a progress from 10.4 to 10.5. XA transactions. There's a problem with XA transaction support. Is that something that you're working on for 10.6, or what's your take on XA?
XA transaction support. There's a growing community wanting to have a XA transaction support so that the cluster could work as a XA resource manager, so that the whole cluster will either accept this XA transaction or and the caller for the transaction monitor can decide that whether he wants to finally commit or roll back this transaction. This has not been possible with the earlier versions. Actually, the implementation for XA, it was possible after we implemented streaming replication. And streaming replication, it can be seen as a foundation for many new features that we are putting out there in the future. And XA will be the first one. We tried to get it in Maria 10.4. We lost the train. We were too late, and we tried to get it in 10.5. It was very close, but there was some other work around XA support in general in MariaDB proper, and our work was competing with that, and we lost that train as well. But now we have the implementation ready, and we are testing with it. We are documenting, and it's definitely going to be in 10.6.
Good. Well, hey, you had a great answer on this streaming replication. Now I think it's clear for many of us what it is. So this meant also that we used up all our time, but great answers and great new features. So thank you, Seppo Jaakola, CodeShip Galera.
Thank you.
And now for a cloud presentation by MariaDB Corporation's Robert Hedgepeth, MariaDB's SkySQL, next generation database as a service from the source.
Hello, welcome to MariaDB Server Fest. Today I'm going to be talking to you about MariaDB SkySQL, a new database as a service offering from MariaDB Corporation. And first things first, I want to introduce myself. My name is Rob Hedgepeth, and I work a part of the developer relations group at MariaDB Corporation. And essentially that means I do anything and everything that I can in order to take the developer's journey and experiences and make them as positive as possible when working with MariaDB. And a lot of times that involves creating content from webinars to sample code, blog post, anything and everything that I can use to really help developers of all kinds in all learning styles basically get up to speed with MariaDB. If you think at the end of this session you'd feel like providing me with some feedback, asking me any questions that you may have after this, please feel free to reach out to me. It's my email, robh@mariadb.com. You can follow me on Twitter or message me on Twitter at probablyrealrob. And if you feel so inclined after seeing some of my code, want to either judge me or follow me, you can find me on GitHub at rhedgepeth. All right, so let's go ahead and jump into this. As I mentioned, we're going to be talking about MariaDB SkySQL, and we're going to take a look first at some of the slides and dive in really to, from a high level, the architecture of how SkySQL was created and planning on being used across multiple different cloud vendors in the future. And then we're going to take a look at some of the capabilities that are provided in SkySQL, and this really helps us set up the foundation that we can use then to jump into some sample code and start looking at demonstrations of not only connecting to and getting started really using SkySQL, but specifically looking at HTAP, or what's known as hybrid transactional analytical processing. And from there, we'll take a look at a third-party integration tool known as Jupyter. It's a notebook application, and we'll see what we can do from an analytics standpoint or a data science standpoint with some large data sets that we're going to be working with. But let's go ahead first and start by diving into MariaDB SkySQL. Well, first things first, of course, is we need to understand what SkySQL is. As I mentioned and said in the title, it is a database as a service. Now, you probably know what a database is, right? Well, if you're at Serverfest, you most likely know what a database is, right? Because you're such a fan of MariaDB, which is awesome. And you can think of a database really as the simplest sense of, a bucket essentially holding something, right? And essentially that something is then persisted, right? So you've got this persistent data storage, and that is the simplest sense of what a database is. Now, this cloud in the background essentially represents a DBAS, right, or a database as a service. And its job really is to provide a layer of abstraction for the database itself. So being able to allow users to use the database without having to worry about things like provisioning machines, installing or maintaining and updating the database, and a variety of other things that goes along with having to install and ultimately maintain a database long term. And obviously, if that's a database as a service, then if MariaDB SkySQL is a database as a service, then essentially this bucket, we can just give it the logo of MariaDB, right? And that's ultimately what SkySQL is, right? But you may be wondering, what's really the difference between SkySQL and Azure databases and Amazon RDS, right? All of those things have MariaDB or flavors of MariaDB. And the main difference from the highest level really is that MariaDB SkySQL runs using enterprise server bits, and RDS and Azure databases run using the community service bits. Now, there's pros and cons, of course, to using community versions and to enterprise versions, and I'm certainly not here to market or sell any of that. But ultimately, that's what the difference is, and we'll see a couple of different ways, especially within the architecture that it's set up, in order to just differentiate really SkySQL from some of the other options that you have out there. And that really starts first with the architecture. If we're taking the highest level view, we're going to look at some of the options or some of the technologies that we used in order to be able to create SkySQL. And you can't get very far into an architecture discussion about SkySQL without mentioning Kubernetes. For those of you who may not be aware, there are these things called containers. And containers can contain any number of things from a technology perspective, but the idea is that they're self-contained, portable, and something that is very popular today, right? And in this instance, we're able to use database instances inside of containers. Well, Kubernetes is a way that you can actually orchestrate or manage those containers. Now, we won't get into the minutia really of things like Kubernetes pods, nodes, and clusters, and talking about the intricacies of that, but essentially we're using Kubernetes, which then helps maintain a level of high availability, among other things, along with MariaDB SkySQL or MariaDB database instances. And so the combination of these two really provide a very robust and modern approach to being able to create what is the groundwork for a database as a service. Now, Kubernetes also has an API which we take advantage of so that we can use cross cloud service providers, right? So if you think of Azure, you think of Google Cloud, and you think of AWS, we're able to use our Kubernetes approach across different cloud vendors. And that really allows it to scale. Now, on the other side, or the other end, we have a front end, and that is powered by something called ServiceNow. Now, it's not necessarily important that we dive into what exactly ServiceNow provides or offers, but essentially what we're using it for is the ability to both configure and manage the inventory and the workflow of the MariaDB instances underneath the hood. And we've peppered in some very awesome kind of modern technologies, open source technologies in Prometheus to handle event monitoring, and Grafana for some visualization, as we'll look at some real-time monitoring of the database that we can do using those tools through SkySQL. From a separation of concerns or a more modular aspect, we use a portal or a front-end portion. We have what's called a control plane, which we'll dive into a little bit after these bullet points, into more of an image view or an architecture slide view, which then helps us communicate with the database or underlying databases that live within the Kubernetes cluster. And all this is really done to provide a high level of compartmentalization, of course, with the modularization, isolation, and ultimately a way that we can control indirect access, right? Even with ourselves, of being able to access the databases that live within SkySQL. Now, here is a high-level view of what SkySQL looks like from a user's perspective, right? If you start from the left-hand side, you can see that what we call customer admins or users, right, log into a web UI that allows them then to be able to control the workflows and the inventory, right, of the databases that, if you look on the very right-hand side, live within the Kubernetes cluster. Now, there is some layers in between there, and that's that control plane that I mentioned before. And its job really is to, of course, relay from left to right, we see here, relay the tasks that are created through any kind of inventory or workflow management into the control plane, which then is going to translate that information into commands to send to the Kubernetes cluster on the very right-hand side. And from there, we can gather everything from, of course, database results, metrics that we can use and flow back into the UI and visualize using those open source tools that I mentioned before. But almost most importantly is the ability to provide indirect access for our Sky DBAs. Now, I'll dive into a little bit more of what it means, the term of Sky DBA, but essentially you can think of it as a MariaDB professional database administrator, right? And they're going to log in using an identity proxy and through a jump server to gain access to the database instances that live within those clusters. From there, they're able to perform a lot of the roles that you would imagine DBAs can, but again, from indirect access, never having direct access to the database itself. Now, from a customer side, you can access the database through a firewall, which we'll dive into as we get into the demonstration a little bit later on, through your applications and third-party clients, and even the MariaDB client, as we'll see a little bit later on, to actually access the database. But that's the overall gist. Now, obviously, all of these things are cross-cloud service provider, as you see at the very top here. So the intention is that this would work exactly the same for AWS, Azure, and Google Cloud. You would just be picking a cloud service provider ultimately whenever you want to use SkySQL. Now, on the other side of that, we have our services that define more of what's available from the actual database as a service part, right, to show what's available from the service of SkySQL. And that really starts from a topology. When we think about how we write code or how we may write applications, a lot of times you don't necessarily have to use the same kind of environment for your production servers as you would for your development or your test servers, right? And so we have different topologies to accommodate this. And on the left-hand side, you'll see that we have a standalone instance. And that standalone instance provides us with the ability to create maybe a test or a development environment. And it's going to come with a variety of functionality that, of course, are available within a multi-node setup. But some of those include transactional, more traditional row-based databases that you can spin up services for if you think of like InnoDB. Analytical services, so if you think of column store, if you're familiar, which we'll get into a little bit more of the details, or even a combination of the two where you can actually combine both transactional and analytical storage on the same server and then even run single queries against those using HTAP, as I mentioned before. And this all is kind of rolled up and available to be able to have real-time monitor against it as well. Obviously, you're going to want some form of configuration because, as we know, MariaDB has a pretty robust collection of system variables and configuration parameters, essentially, that you can set in order to make it tuned and run really well for your workload. We wanted that to be available, of course, within SkySQL and highly customizable, as we'll see once we get into the demonstration. With any professional database, of course, there needs to be disaster recovery and automatic backups, which happen nightly. Point-in-time restoration, of course, if you needed to go back in time to restore your database at a certain point. And as I mentioned before with Kubernetes, there is the ability to provide this high availability through something called self-healing. Essentially, when a Kubernetes pod were to die or go down for a variety of reasons, then it would self-heal itself so that pod would spin back up and be able to be very resilient that way. On the other side, or on the right-hand side here, we see a more multi-node setup where you'd think of a production environment. And in cases like this, you can use something that's in tech preview now through our expand product, which is called distributed SQL. And distributed SQL is basically being able to take database and spread the information out using this thing called a slice or slices onto the machine or the nodes for massive amounts of information, right? So we're talking billions, tens of billions of records being distributed throughout these nodes. And we'll see that as an option as we dive into the SkySQL portal a little bit later on. Of course, even more high availability, right? So as you create more nodes and you have these primary replicas, you have, inherent advantages, right, from the cloud service providers through multi-node deployments and replication. There is a product in MariaDB called MaxScale, which you've probably heard of, which is simply just a database proxy. Not simply, it is at the highest level of database proxy. And of course, that provides all kinds of capabilities like automatic failover, transparent query routing, read-write splitting, and a variety of other features, which it's good to know about, but we're not going to dive into as in depth with this particular session. And lastly, before I jump into the demonstration, I want to talk a little bit about SkyDBA, as it is a distinguishing factor about MariaDB SkySQL. Essentially, as I mentioned before, you get the MariaDB professional database administrators, which provide everything from consulting types of support, which include health checks, performance analysis, and security audits. But the main takeaway here is that when you think about a database administrator, it's very rare that you get a situation where the actual professional, so the company and the group that built the database, provides database administrators as a service, right? And you may find that in, if you think of other, cloud databases like Mongo, right? Mongo's Atlas. You may find it in situations like that, but it tends to be a very sought after type of service because it's rare that you would find that professional that works for the source that's actually building the database as well. Okay, and that brings us to our demonstration. So what we're going to do first is we're going to dive into the portal of MariaDB SkySQL, and I'm going to take you through a tour where I'm going to show how you would look first at launching a service, a database service that you can use, and what all is really entailed in setting up that service and how easy it is to get done. But beyond that, we're going to take a look at some of the other features that start to distinguish SkySQL from other databases as a service that exist out there. And then that's not to say, from a sales perspective, but really just this exists here, and this is why we think it's important type of perspective. And then we're going to take a look at a sample where we build two databases, and in those two databases, we're going to provide two different types of tables, right? Where we're going to be looking at NODB tables, and we're going to be looking at column store tables to combine into an HTAP instance that we can use to show off the power of HTAP within MariaDB SkySQL. So let's go ahead and flip over to SkySQL. All right, so this is the portal, again, powered by ServiceNow for MariaDB SkySQL. You can reach it by going to cloud.mariadb.com/SkySQL. And when you do, you're first going to be asked to actually launch a service. So the screen is going to look very similar to this, where it's going to ask you to launch a service. And you've got a couple of different options here. On the very left-hand side, you've got the simplest example of a transactional-based system, right? Where you're using row-based data storage that stores the information in persistent block storage. Next to that, you have something called analytics. And analytics is simply looking or storing analytical information that exists in MariaDB column store. So a columnar database, which is different, of course, than a row-based database, but is really more for looking at large amounts of information without indexes in more of an ad hoc fashion. And there's a couple advantages to being able to use columnar storage, obviously beyond the performance implications that you get. It's also stored within low-cost object storage for each of the cloud providers. So it's a little bit different than the way you would store transactional information in persistent block storage. You're actually able to store this in object storage. And then on the very right-hand side, you can see that we have this both option. And in parentheses, it says HTAP. And that stands for Hybrid Transactional Analytical Processing. And that essentially is the combination of transactions on the very left-hand side and analytics in the middle portion here. And being able to combine both row-based and column-based data storage mechanisms in a single query, which we'll certainly get into. And lastly, something that I'll mention, but we won't really get into too much, is the option at the bottom, which is still in tech preview, but it's something called scale out transactions. And I briefly mentioned it before, but this is this idea of distributed SQL, where you're able to split large amounts of information over multiple nodes and be able to still have a very low latency and high availability available to you within the service itself. So if now we want to go ahead and launch a service, let's go ahead and start by looking at transactions. So I'll click launch, and it's going to, of course, give me a description of what transactions is in the form of MariaDB platform and on MariaDB SkySQL. But the first thing that we're going to see is that we have a topology which allows us to pick either a standalone instance or a primary replica setup, or that multi-node instance that I had mentioned before. Now, for this demonstration, we're just going to go ahead and stick with standalone, as we're just using this to basically develop on or to test some of these integrations with. Next, you'll be prompted to pick a region. And we've got, as you can see, 3 regions within the US, 1 in Asia, and we have 2 regions within Europe. After that, you're going to hit probably the most important part of this selection process, which is looking at the resources that you want to use for your database instance. And that's going to be based on 2 things, right? You're going to have the amount of CPUs, or virtual CPUs and cores in this case, and the amount of memory that you want to use. And it ranges from everything from 4 CPUs by 15 gigs all the way up to 64 by 416. And on the right-hand side here, you can see probably the most important part of this table is the price. And it gets drastically more expensive, of course, the larger the machine gets. Next, you'll want to take a look at the amount of transactional storage that you want to have. And this depends, right? So if you're a transactional database service instance, and that's solely what you do, it may be that you want more. If you have analytical and you need some kind of persistence disk storage of some sort, you may pick less. But it ranges from 100 gigs all the way up to 6 terabytes. And of course, has a factor on cost as well. From there, you'll want to pick the MariaDB MariaDB Server version. And right now, there's currently 2 versions of 10.4 and 10.5. Because MariaDB was released back in March, and the summer release for 10.5 happened just a little over a month ago. Then you simply pick a service name and click Launch Service. And for the sake of time, in the instance of saving time for the demonstration, I've gone ahead and created some services. So I'm going to go ahead and click Your Services on the left-hand nav, and I'm going to leave this set up because I've actually created an instance that's exactly the same that we're going to use for an example going forward. Now, when you see this, you have a table. Mine just has 1 entry in it. But this table contains a lot of the same information we just looked at whenever we were launching our service. And really, the only thing that really stands out here is a little bit different are the health check in states. And it's simply just telling you what the service is doing right now. And right now, of course, we can see that it's healthy. So we can click on this row and go into the instance itself for more details. Of course, it's going to give us the name of the instance, some versioning information, and then the configuration that we chose. But what's new to us here is that in order to be able to connect to a database instance, we need 2 things. We need a fully qualified domain name, which we see here just towards the middle, and we need a read-write port number. So we need a port to actually access the database instance on. Beyond that, as I mentioned before, we have the ability to add custom configuration. Now, currently, this is a fresh instance, so I haven't done that. But if I wanted to add a custom configuration, I can either click Manage Custom Configurations here, or I can look at the left-hand navigation and I can say Configuration Manager. And I point this out, really, so that, 1, we can see all the configuration options that are available, at least from a brief glance, but also to note that there are already some defaults that come out of the box that you can choose and that you can clone, or you can create fresh configuration values altogether. For this, we're going to go ahead and take a look at what I've already created as Rob's HTAP configuration. Now, as you saw whenever you first saw, and you can see here at the title, it says Rob's HTAP config 3. If I were to minimize that, you can see that it has gone through a couple of iterations. And that's because every time you change a configuration value or some kind of variable within this configuration set, it's going to version that. And that's important because if we've got multiple database instances or multiple services out there using this configuration, we can upgrade or keep the same just depending on how we want to use this configuration setup. And as you look inside of this table, you can see all kinds of configuration values. Now, they all have a default setting, but if you want, right, you can scroll to the top here and you can click Actions and Edit Configuration. This allows you, through a series of drop-downs, to go ahead and change these configuration settings. So if I go down to the bottom here for my timeout, maybe I want to decrease that 600 seconds, and I can save. And I'll see that I actually then get a version bump. So now we're at v4, and it saves the previous version history. If I navigate back to my services, back into my HTAP demo service, I'm then able to pick a configuration for my HTAP service by picking the little gear on the right-hand side, and then I can choose a custom configuration, which is filtering it based on the service instance type that I'm using, which is HTAP. Can apply it, and it will apply those configuration settings. So pretty easy, but also pretty robust and configurable. Now, From an access point of view, I mentioned before this idea of a firewall. And in order to be able to access MariaDB SkySQL, you're going to have to enter either an IP address or a range of IPs. And that's going to be done by clicking this little pencil on the right-hand side and then simply entering in your IP address. Now, I've already done this for the sake of saving time, and so I'll already be able to access this service. From there, you have the ability, of course, to stop the service, delete the service, and most importantly, for being able to access this service, you want to look at Show Credentials because it's going to give you the username, the original or default password, the ability then to download what's called a certificate authority chain. It's simply a certificate that you have on the client that you then can give to the server to say, hey, I can talk to you through SSL. And then you're going to get a couple of points here which are going to remind you, hey, you've got to add your IP address to the whitelist. Here is some sample CLI you can use with the MariaDB client. And you probably want to change your password to something that isn't as gobbledygook as what we provided, but also is a little bit better than the new pass, which you see here as the example. Now, before we jump into the integration portion of this, I want to go ahead and take a look at the left-hand navigation to point out some of the features that exist in MariaDB and the state of which they're in, but also some of the potential that some of them have. So we're going to start by taking a look at the workload analysis portion that you see here on the left-hand side. And this is still in tech preview, but as we know, workloads can be pretty complex, right? It's not as easy as write first or write only, a read-write based workload. Oftentimes, your workload can change drastically on weekends, on nights, on holidays. And so we've combined some machine learning models with the data that you start to accumulate in your databases really to understand and be able to optimize the workloads that exist within the databases that are used within SkySQL. And so this is something that's still in development, so I heavily suggest at least reading about it. It's pretty cool from a machine learning perspective, the things that we're looking to do. Now, it's still in its infancy, so it's got a lot of work to go before we can start getting into the optimization and some of the predictive things that we'd like to do with workload analysis, but it's pretty cool. Now, beyond that or below that, we have the capability that I've brought up a couple of times, which is real-time monitoring. Using Grafana and Prometheus, then on the data that you're storing inside of the instances, we're able to do some event monitoring and look at things all the way from the CPU workload to a query analysis to just query workload in general. A lot of really cool things that we can actually look at in a real-time perspective to give you feedback on your databases and the database instances underneath. Of course, those are whitelisted as well, so you would need to add any whitelist IPs for any access that you'd want to have into monitoring or workload analysis. You have the ability to go straight into MariaDB SkySQL directly from this link, and of course you can reach out to MariaDB support if you need to. And with that, I think it's time for us to actually step into some code that we can use to see exactly how we connect to and integrate with SkySQL, but also be able to use and look at HTAP so that we can check out our second example, which is in Jupyter. All right, so let's go ahead. For this part of the demo, I'm going to be taking a look at a GitHub repository that I've already created in order to pull down and show how we can actually connect and communicate with SkySQL. And then we're going to take a look at an HTAP database to see exactly how we can use things like cross-engine query to look at both row-based information and column-based information. So I'm going to start by opening up a terminal window, and I'm going to do a little bit of a cheater here, and I'm actually going to bring in my git clone command. And actually, I'm going to go ahead and take a look at a specific folder and load my terminal window there. And here, I'm going to actually pull down my repository, clone the repository, so that we can use some of the bits inside to actually communicate with SkySQL, but also create a schema and load the information in there. So let's go ahead and pull down our repository now. All right, so now that I've pulled down the repository, you can see that I've pulled it from MariaDB Corporation GitHub account and a pretty long name here of dev example SkySQL htap quick start. So because that's so long, I'm going to use the CD and I'm going to paste in the name of that folder. So once I'm in that folder, I can see that I've got quite a few things between files and folders. But to give us more of a visual appeal, I'm going to actually open up an instance of Visual Studio or VS Code to go ahead and take a look. So let's go ahead and go into my server fest directory, and I'm actually going to use this entire folder. Take a look at my repository. And the first place I want to start is by taking a look at a create and load shell script. Now I've combined everything inside of a single script, right, so that I have the ability to both display what's going on here all in a single file, but also keep the time for the demo down without me having to go back and forth and entering in commands, or even worse, probably typing those out and fat fingering everything. So as we get into this shell script, we can see that I am simply using the MariaDB client, and I'm providing it things like the qualified domain name, the port number, the username, the password, and that SkySQL chain PIM file, which is the certificate authority chain file that I can use on the client to tell the server that I can connect. So before I can use this shell script, I actually need to go back out to SkySQL, and I need to download this file. So I'll download the file. I'm going to show in Finder, and let's actually go and click back over into my Visual Studio Code. I will bring in my SkySQL chain PIM file, and I'm just going to drop that directly inside of my Explorer window. And that's because I relatively use it from this spot, right? The same spot that create and load shell script lives. From there, once I've connected, I want to go ahead and use a couple of files. So I'm going to use a SQL script idb_schema and cs_schema, and these are going to allow me to create my travel database, which contains my InnoDB tables, and my travel history database, which contains my column store table of flights. And then I'm going to load information into these tables. So I'm going to start by loading airlines, a collection of airlines into the airlines InnoDB table using a CSV file. I'm then going to load a collection of airports into the airports table on the InnoDB side. But then I'm going to actually use a CSV to load about 700,000 records into a column store table on the travel history database. And this is going to allow me to have two different schemas with different collections of tables, but after I load that information in there, we're going to take a look at something called a cross-engine query, where I can actually combine and join tables from the InnoDB side to the column store side in a single query. So let's go ahead and load this script, or run this script. So I'm going to start by opening a terminal window. One of the reasons why I love VS Code. So I'm going to open a terminal window directly in the code editor itself. And from there, I'm going to CD, and I'm going to actually attempt my hand at actually seeding into my quick start. Hey, first try. And from there, of course, I have the ability to run the shell script. So now I'm going to cheat a little bit, and I'm actually going to paste in the command, which is essentially just running my shell script and giving it the arguments of my domain name, my port number, username, and my password. So I'm going to run this script, and it's giving me a little bit of feedback here saying that it's created the schema. I've gone ahead and I've loaded both the airlines and the airports information using a CSV. And now I've actually loaded the flights information into the flights column store table. To confirm this, I'm going to connect using the CLI quick command here of being able to use MariaDB, going to enter in the password, and now I'm actually inside of MariaDB SkySQL. And I can confirm that my script worked by typing in show databases, where I can see that I've added in travel and travel history. Now, to confirm that I've got information inside of travel and travel history, I'll first start with travel, and I'm going to use that database and just go ahead and take a look at the amount of information that's inside of my airlines table. So we've got 30 records that exist inside of my airlines table. Now, if I wanted to be able to use my information that now exists inside of my airlines table with my flights table, I'm going to be using something called a cross-engine query, right? So here I can tell that I have from travel history, since I'm in travel at this point, I can see that travel history, flights, I have about 700,000 records. So if I want to combine that, I can simply, using HTAP, I can simply write a single query, which is going to allow me to use a cross-engine query or cross-engine join around those, or using those two data storage mechanisms. So I want to type a.airline. I'm going to create an alias after this, obviously. And I want to type, I want to get something like the average delay, the average delay from flights. So the departure delay is a field that is held within the flights table. And from there, I want to actually say, I want to use travel.airlines. I'm going to give that an alias of A. I'm going to interjoin that with travel history.flights F, and I'm going to join on A dot something named as an IATA code, which is the equivalent of the carrier which exists inside of the flights table. And then from there, I want to group by my A.airline for my airline field, and then I can simply, looks like I actually have an issue. Let's see, select airline flights delay from travel airlines A from, oh, inner. I guess I need to actually join the two tables, so you can't just do inner, means nothing at all, obviously. So I can do inner join. Now, I have the information from both of those two data sets. And I can simply use any kind of, I can modify this if I wanted to order by the actual average so that I can get some a little bit easier to read information on the delay itself. Again, I am the best at leaving out words, so we actually want to order by, but then that gives me the ability to look at which actually has the best departure delay, and of course, being able to show, it's a little bit more important to me, which ones have the worst, so I can avoid those particular airlines in the future from, and I could dive into different airports and where that may happen. But this allows us to look at a cross-engine query. Now, doing this through the client isn't exactly exciting. So what we can do is, on the second part of this demonstration of looking directly in the code and communicating with SkySQL, I want to show how we can use something called Jupyter Lab. And Jupyter essentially is an open source third-party notebook application that I can use to be able to run. In this case, I'm going to be looking at Python and using the MariaDB Python connector to connect to SkySQL, bring back the data from a cross-engine query, and then be able to display that using both the log output in code and also a visualization library called Plotly in order to show some graphs with this exact information. So first I'm going to, on this left-hand side of my Explorer window, I'm going to create a directory called Jupyter. And I am actually then going to exit MariaDB in my terminal, and I'm going to back up so that I can cd into Jupyter, and from there I simply want to type in Jupyter Lab. Now this is something that I've already installed, so it's going to work, but the process is extremely simple. So I want to kick off Jupyter Lab, and once I do that, I want to go ahead and remove this here. Whoops, I want to bring up my Jupyter Lab notebook, and I want to create a new notebook. So I'm going to select Python 3, and essentially I just have a Jupyter Labs notebook, which is untitled at this point. I could rename it if I wanted to, but what I want to do is start to incorporate the usage of the MariaDB Python connector to connect to SkySQL, and what that may look like briefly in code, but more importantly, how I can use that information from a data science perspective, right? Use the HTAP information and start to build visualizations that really help me get a better idea of the data underneath. So I'm going to go ahead and paste some things in here for the sake of time, but I'll explain them as I go. So first, I'm going to import the MariaDB Python package, which is the connector for being able to connect to MariaDB databases. I'm also going to be bringing in Plotly, which is a visualization library that I'm going to be using to create some graphs. From there, I really want to create the configuration, because in order to connect to SkySQL, I actually have to provide a configuration. And this configuration needs to have SkySQL parameters. So as I look, I actually in here need to provide, it looks like I have the appropriate information that I need to for my SkySQL connection. Whoops. From there, I want to actually make a connection to MariaDB. And I can do that by using the connect and entering the configuration, which is going to use the information of my domain, my port number, my username, and my password to connect to MariaDB. Now, all in an effort to be able to create a cursor. The cursor, then I can be able to execute a query. And in this query, I'm now going to have the cross-engine query, right? So the exact same or pretty close to the query that I just had, where I'm selecting airline. I'm selecting an average of the departure delay from my flights table based on the joins that I have of carrier. And then I simply want to fetch my results. Now, I can simply output this information, right, by printing it. That's something that obviously that I can do. So if I first go ahead and enter in a function then to call, make sure I get my indentions right in Python or it will not be running. Go ahead and enter in a call to print underscore stats. And this is simply going to print the top 10 of that cross-engine query. But as you can see, incredibly fast, and it's combining the information from both the row-based mechanisms and the column-based mechanisms. But this isn't very interesting to me because from a data science perspective, I really want to start to drill down in that information and use things like visualizations. So now that we've actually already brought in the Plotly code or the Plotly import, now I can actually bring in a method, and I'm pasting a lot of code in here, but essentially what I'm doing is I'm going to be passing in my results, and then from the information that I've gotten from the results, I'm actually going to build both a bar graph and a pie chart. And then I'm just going to simply show those using this notebook and really the power of this notebook to be able to do some analysis in real time. And of course, if I want to be able to show this information, I can simply just add a call underneath and be able to execute. And so we can see that not only did I get my tabular information, but I also have a bar chart and a pie chart, which allow me to take a closer look at the information from a visualization standpoint. And this is really just the beginning of what you can do using tools like Jupyter, or there's other ones like Zeppelin, but they're pretty cool, and it's really fun actually to be able to write a cross-engine query, which combines the information from your row-based, which is something that you normally do, but being able to combine millions or tens of millions, billions of rows in aggregations on the analytical side is something from, as a developer, it just changes the way that you can write applications. So this is something that it's definitely available within SkySQL, but we also recently created a community server release 10.5 that actually includes the same capability as well. And the cool thing about that is that not only do I have samples that you can actually go and pull down from GitHub using MariaDB SkySQL, but I've also, in each of the samples, provided a way that you can connect to the community server container, which exists out in Docker Hub, to be able to do the same thing. So no matter how you do it, I suggest, if you're interested in checking out things like HTAP and looking in some of the newer things that MariaDB has been doing, go and take a look at those developer samples at MariaDB Corporation GitHub/developer-examples. Also, if you want to try SkySQL, it's completely free. You get a $500 credit to be able to start, and you can spin up transactional, HTAP, all of the service instances that we went over pretty easily. And if you have any questions or suggestions for any of this, feedback from me, I definitely appreciate. Please email me either at robh@mariadb.com, or you can email me at the alias of developers@mariadb.com. It also comes to me. Be sure to follow MariaDB if you're not already. And check out, again, the MariaDB Corporation GitHub account where I've put just tons of samples. And thank you very much for attending MariaDB Server Fest. I hope you have a great rest of your conference.
Robert Hedgepeth, MariaDB Corporation, SkySQL, great presentation. Thank you for being here, and thank you for calling in from, I hear, from Chicago, are you?
Yes, Guy, thank you very much for having me. Yeah, I'm in the beautiful, for now, city of Chicago. Hopefully it won't get too cold too quickly. We'll see.
Mm-hmm. So I usually start by asking a very simple question that you probably already answered a couple of times in your presentation, but still we need to start from the basics. So why use a database as a service instead of going simply on-prem?
Yeah, it's a great question. And, a lot of time that's going to be situationally based, right? And the situation that I would come into that leaning towards is, to give a little context, is that I am an application developer. So I don't know a lot, and I'll be the first one to tell you, I don't know a lot about things like provisioning machines for databases. I don't know, the ins and outs of configuring MariaDB at, the deepest level in order to optimize it to work on the provisioned machines. And where a database as a service can help is that it really abstracts away a lot of those steps, right? So that I can focus on application development. Now, it doesn't necessarily have to be just for application development. Development right now is a very broad field, right? Very broad industry. And we're seeing more and more that, things like automation engineering is becoming popular, DevOps engineering. And a lot of these folks don't understand the intricacies and, the details around, kind of managing a database, what would be, say, on-prem. And so having that abstraction then gets them from A to B and getting back into working on the apps or, in their developer operations processes that much quicker.
So that sounds very similar to what we heard on day one from Supermetrics, who are using or moving from on-prem to SkySQL. And they said that the reason SkySQL is so interesting for them is, on top of what you just said, they spoke about being cloud agnostic. They wanted to be not dependent, not do vendor lock-in on a specific cloud. So how do you relate to that?
Yeah, I think that I would have the same sentiment. I think that as we're seeing now, these cloud players are becoming larger and larger, and they're having more and more services that they provide every day. And it increases, that attraction really to be locked in, right? Where you key into a particular service or set of services. One of the things that's really beneficial about SkySQL is that at the beginning, we thought of that and used Kubernetes and ultimately the Kubernetes API to be that mechanism to really maintain the database instances, right? And I won't get into the intricacies of that, but essentially it provides a very standardized way to be able to do that on whatever cloud provider. So from our side, in the way that we develop that, it makes it easier to be able to manage those and provide those really on GCP, which is where SkySQL currently is available now. It will be available on AWS and Azure in the future. But then, like you had mentioned, this allows, anybody out there that's like, well, I want to switch from AWS to GCP, and being as though SkySQL is database agnostic, then they can really be able to do that, rather than if it were just offered in one place, or they were happy to use it in one place, then they don't have to necessarily get locked into everything there. And so you get this ability to move around. And one other thing that I would say is, more and more hybrid cloud situations are becoming popular. And so you certainly don't want to get locked into a particular cloud and only be restricted the access there. In hybrid cloud situations, you can then be able to go private. You can use different cloud providers, all of which are supported using MariaDB SkySQL, and really any database as a service that is multi-cloud.
Mm-hmm. So let's say that I'm now interested. I got somehow curious about this, and I want to kick the tires a bit. So what kind of advice do you have for me if I want to test it out?
Yeah, so the first place that I would start is cloud.mariadb.com/SkySQL. And there you're going to be able to sign up for SkySQL. Now, what that involves is that you would create a MariaDB ID, and then you would then register for SkySQL. And it is going to ask you for a credit card for now. It asks you for a credit card, and the good thing about that is, though, because I know that everybody out there reflex is like, I don't want to, slap down a credit card, right? The good thing about that is that there's a $500 credit. So essentially, you can spin up, I showed HTAP, or using hybrid transactional analytical processing as a service. You could use a transactional service or columnar. You could use everything under the sun up to that $500 limit before you'd get charged. So that's a really good way to try that out. The other thing that I would mention is the sample that I kind of went through, or the demonstration that I went to today, is available in GitHub. As I mentioned, and I've got a variety of other ones at MariaDB-corporation/developer-examples. So on GitHub, the MariaDB Corporation account, all of the examples include integrations of how you would communicate or connect to SkySQL and then be able to use those samples with SkySQL. But they also are all available and allow you to point to MariaDB Server as well. So using, maybe a container, maybe you want to install MariaDB locally. All of the things that I went through that involve, working with SkySQL, you can also try those samples as well on MariaDB Server. So whether you want to try it or not, I highly suggest checking out those developer examples just to get a taste of using MariaDB, no matter where you use it.
So speaking of developer examples, I have a suggestion for you. Tomorrow there's a session by another Robert Bindar from the MariaDB Foundation on specifically something that you were demoing here, which was the Jupyter notebook stuff. There's going to be some integration towards that being showed. So hey, these were great answers to some simple questions that I had, and a great demo, great presentation. Thank you, Rob Hedgepeth, for a good presence here at the MariaDB Server Fest.
Yeah, this has been great. Thank you very much for having me. I appreciate all the questions. Anybody who wants to ask me any more questions, feel free to hit me up anytime, any place. I am in Chicago, but I'm basically now with the new infant. I'm awake all the time. So feel free to send me all your questions.
Okay, we will do. So that was it for today. I hope you liked it. If you did, feel free to share it on social media, LinkedIn, Twitter, #MariaDB Server Fest. And tomorrow we'll continue. I would say same time, same channel, but the channel won't be the same. There's a new YouTube link, and you'll find it on mariadb.org/fest2020. So see you tomorrow.